is essential for addressing cattle-related greenhouse gas emissions, which we have attempted to do, and it's also essential for effective planning and management. So for now, we can work with this information, but we need to improve it further. Going forward, we're saying that the aggregation of districts and regions into eco-zones must be backed by available literature, or if we have the resources, we should go down to the field to gather this information. We should work with the necessary government institutions to gather the basic information that we need to further improve this work. If amassed cattle breeds into broad groups of large and small frame, we need to know the exact number of breeds, their proportions, and how each of these breeds responds to improved feeding and ultimately their effect on greenhouse gas emissions. The exact practices of the production systems are known. We have the free range, we have the store feeding, we have the dairy. Cattle, but into broad groups of large we made some, should I say, expert judgments to arrive at that. We are developing each of these breeds response to some elicitation to send to each and every one of us to help us wherever you can find yourself. The animals, the exact practice within your area. Provide some information. We are going to share the link when this is over, so you can each log on and provide information. Then we can further process that, break it down into regions, into zones, and we will further improve this way. So please, when the work comes, the link comes, where we may improve that. Some, should I say, expert judgment. There is lack of detailed health structure on private farms. I think I have explained that already. And so if we go down, we send our technical experts to the field. We've been told that we can roam the whole country, you won't get the information. We are working hand in hand with the Ghana National Capital elicitation to their leadership, so they can link us to wherever you can find the people who matter on the field to get this information. And until we get that, we will continue to provide some information. We are going to share these low numbers from, is it 1.1 to 2.2 over 3 decades. Further process that. It may be 7 efforts, but not as much as we want it to. Then the information on transhuman cattle. We know the animals that we made in, they come, they move often in the night, they don't move through city centers until they get to places where they have to cross bridges and things like that. But we are hoping that we can improve that information going forward. When we depend on the government set up cattle movement corridors and grazing reserves that we intend to. Some other work is working on that we'll be able to access data for that. Hand in hand, improve with this work. Ghana National elicitation, their leadership, so they can link us to. I think you might need to further check on this. Thank you so much. Area, get that. Provide some information. We are going to see these low numbers from, is it 1.1 to 2.2 over 3 decades. Further process that. It may be 7 efforts, but not as much as we want. Then the information on transhuman cattle. We know the animals that we made in, they come, they move often.
Thank you very much, Dr. Domozuru, for helping us to appreciate how our cattle population, from a single number, the team has been able to categorize it to meet the standard, so we can report on IPCC Tier 2. In view of time, we cannot give every details of this project, but at least the overview has given us all the emissions and the range of emissions. There's one particular emission that, as a country, we don't really pay attention to, and therefore, I would like to take the opportunity to talk about it. So, the next presentation, I want to spend some time to talk about indirect emissions of nitrous oxide from manure management, and direct and indirect nitrous oxide emission from dung and urine deposited on pasture. This is important because most of our cattle
Then
are on range or extensive
population of
system.
trans-human cattle. You know,
And
animals
the emissions
come
that
often
their dung and
Thank you
urine,
very
and
much,
the emissions
Dr.
that
Domozu,
come out
for
of it,
helping
usually
us to appreciate
we don't
how
really pay attention to it.
our
We are
cattle
more
population
concerned with
from
the
a single
methane,
number,
and
the team has left the nitrous oxide. But
categorize it. We should
meet
note
the
that
standard
the
report
global warming
IPCC
potential of nitrous oxide is about 280
of time we cannot
times higher than that of carbon
every
dioxide.
details
Comparing
of
it with methane, methane
project.
is between
But at
25
least the
and
overview
28.
has given
So you can
us
see the
all
magnitude of
emissions
what
and
nitrous
the
oxide can
emissions.
cause. In
There's
terms
one
of global
particular
warming.
emission that, as a country, we don't really pay attention
So I'll
to. And therefore,
divide this
I
presentation
would like
into
to take the
four.
opportunity to
I'll talk about
it.
indirect
So,
nitrous oxide
the
emissions
next
from manure
presentation, I want
management.
to spend
Talk
some
about
time
direct
to talk about
nitrous oxide
indirect
emissions from
emissions
dung
of
and
nitrous
urine
oxide
deposited
from
on
manure
pastures.
management.
Then
And direct and
indirect
indirect
nitrous
nitrous
oxide emissions
oxide emission
from dung and urine deposited on pastures.
deposited on
And
pasture.
then talk about
This is
improvements
important because
of this
most of our
inventory. This is the first
cattle
time, and
Then
as
on range or
IPPC
extensive
is required
every 2 years,
and
we need to
the emissions
update
that or improve upon what we
their
have
dung
done.
and urine, the emissions that come out of it.
Usually.
Us to
So I'll
don't
first
our-
of all begin with
pay attention
the
to
sources
it.
that
We
I'm
are
going to
more
talk about,
concerned with the
which is
single
highlighted in red, and
the team
cattle
has left
manure
the nitrous
management,
oxide. But
and
we
the
should
dung
note
and
that
urine deposited on pasture.
the global warming
And this
potential of nitrous
data
oxide
that I'm going to show you is
is
based
about
on country-specific
280 of
values. We
times
use higher than
our
that
own feed,
carbon
every
dioxide.
details
Comparing
of
it
this
quality,
methane
determine the other
but
unit.
at least
We
the
use
overall
our own
you can see
reproductive
the magnitude of
performance of our
nitrous
own
oxide can cause.
cattle.
There's one
But tier one
particular
does not take into consideration
don't
the feed,
Yeah,
so I'll
and therefore
divide this
I
presentation
would like
into
to take the
four.
opportunity
I'll
to
talk about
it.
indirect
So,
nitrous oxide
the
emissions.
next
from manure
presentation I want
management.
to spend
Talk
some
about
time
direct that, so that we
talk
can have
about
country
nitrous
specific
oxide
emissions, not just the
emissions of nitrous
population.
oxide
on
from
pastures.
Then
Then
indirect
indirect nitrous oxide emissions.
oxide
So I begin with the
from
indirect
deposited on
emissions of
pastures.
nitrous oxide from
Then
manure management. Talk about
This is
improvement. Talk about how
this
we arrive at those values I showed you earlier. So regarding methodology, the IPCC 2006 equations were used. And this equation
Most
only
of them-
focuses on
this is
emissions
the first
of
time
nitrous
IPCC
oxide from
required
nitrogen
every
losses based on
and
only
the
volatilization.
emissions
But
or improve
that is not all. Nitrous oxide emissions from bleaching, well, first of all, is also important. So we updated it using the IPCC 2029 updated
But
the dung and urine deposited on pasture.
the global warming
And this
potential of nitrous
data that I'm going to show you
is
is based
about
on country specific
280
values. We use higher than
our
that
own feed,
carbon
every
dioxide. Comparing it quality, determine the other
but
unit.
at
We
least
use our own
reproductive
reproductive performance of our
nitrous
own
oxide can cause.
cattle.
There's one
But tier
particular
one does not take into consideration the feed, so I'll
Therefore,
divide this
I
presentation
would like
into
to
four.
I'll
I'll talk about indirect
So,
nitrous oxide
the
emissions.
next
from manure
presentation I want
management.
to spend
Talk
some
about
time
direct that, so that we can have country
nitrous
specific
oxide
emissions, not just the
nitrous
population.
oxide
Pastures,
then
then
direct
indirect nitrous oxide emissions. So I begin with the indirect emissions of nitrous oxide from manure management. Talk about
This is
improvement.
meant
Talk about how we arrive at those values I showed you earlier. So regarding methodology, the IPCC 2006 equations were used. And this equation only focuses on emissions of nitrous oxide from nitrogen losses based on only volatilization. But that is not all. Nitrous oxide emissions from bleaching, well, first of all, is also important. So we updated it using the IPCC 2029 updated dung and urine deposited on pasture.
global warming
And this potential of nitrous data that I'm going to show is based on country specific values higher than our own carbon dioxide. Comparing it quality determine the other use our own reproductive performance of our own cattle. There's one, but tier one does not take into consideration the feed. So I will therefore divide this presentation like four. I'll talk about indirect nitrous oxide emissions. The next presentation I want to talk about direct so that we can have countries of indirect, not just of nitrous oxide ashes, then indirect nitrous oxide emissions. So I begin with the indirect. Emissions of nitrous oxide from then talk about this is meant talk about how we arrive at those values I showed you earlier. So regarding methodology, the IPCC 2006 equations were used. And this equation only focuses on emissions of nitrous oxide from nitrogen losses based on only volatilization. But that is not all. Nitrous oxide emissions from methane, first of all, is also important. So we updated it using the IPCC 2029 global warming, this potential nitrous data that I'm going to show is based on country specific values higher than our own carbon dioxide. Comparing it quality determine the other use our own reproductive performance of our own cattle. There's one, but tier one does not take into consideration the feed. So I will therefore divide this presentation like four. I'll talk about indirect nitrous oxide. The next presentation I want to talk about direct so that we can have countries of indirect, not just of nitrous oxide ashes, then indirect nitrous oxide. So I begin with the indirect. Emissions of nitrous oxide. Then talk about this is meant talk about how we arrive at those values I showed you earlier. So regarding methodology, the IPCC 2006 equations were used. And this equation only focuses on emissions of nitrous oxide from talk about. This is meant talk about. So regarding methodology, the IPCC 2006 equations were used. And this equation only focuses on emissions of nitrous oxide.
Regarding methodology, the IP 2006 and this is basically only because of emissions of nitrogen oxide.
then we can call them true dairy animals.
Thank you. Any other question for us? Oh, sorry, there's a hand here, please. Yes. Yes. In reality, it is. But according to the IPCC requirements, you can't use population that you are not sure that it will be done on regular basis, at least every 2 years. The Ghana Cattle Farmers Association data, to us as researchers, look more realistic than that of the MUFA straight one. But the issue is consistency. In future, if they are able to do maybe 3, 4, 5 times, it's a bit consistent, so we can adopt it. But for now, it's the first time. So for consistency, if you use that, the report will come back for revision because it doesn't meet the IPCC requirements. And before it's accepted, they will check. At least they will check the population. And the National Ghana Farmers data is even not online. So they will think we have more or less put some data. So we hope that they will get the funding from an NGO or whatever source to continue. And then we will encourage them and put it online. Once it's accepted by MOFA and other agencies, then we can use that. So with the IPCC, consistency is a very, very critical. So we know that their record is credible because they know where their farmers are and they communicate ahead of time before they go, so they get accurate data. That is why I was recommending that we have to work with them as well as MOFA to get credible data by using vaccination. It has been done elsewhere outside Ghana, and they were also having a similar problem like ours. But when the government agreed to use the vaccination program, so this one will involve vet officers, MOFA, some public university, research institutes, and then the farmers, some of the farmers leaders, and it makes it easier.
Yeah, thank you very much. Again, I saw you dwell more on the 1990 data rather than the current ones. However, my issue now is it possible that you develop a model which can be used to estimate rather than every year or every 2 years going back to the field and trying to do that kind of data collection?
So thank you. Probably I didn't highlight that point well. A greenhouse calculator has been prepared by IPCC and Ag Emission New Zealand for Ghana. So the effort we put in arriving at this in 2 years, it will require far less effort now because, one, even manipulating the calculator was a problem. It took us more than a month to learn how it works. But now we know how it works. And now we know the gap. So the improvement that we need to do will be based on filling the gap. So we are not going to start over everything, but rather, for instance, if you take seed, we reviewed material up to last year, to 2024. If any of us have done some seed quality analysis on any of the seeds that we use, we will update that one. But the old one still stands. So it's improvement over the years. So we are not going to start from scratch, but we are building on what has been done. Selassie has another question. So,
Oh, okay.
Yeah, just to indicate that there's a model. The GAG calculator is in place. So we will not be doing it as we've done now. Going forward, we only need the inputs and you can project into the future. So I'm sure at a point in time, we have to make the model available to your team so that others can also have a look at it. Thank you very much.
And also, we are also making use of improved information. So like he's saying, if we do more work in areas that we haven't done before, it goes to enrich that. And if, for instance, we change some of the practices, manure management, if we are doing a lot more deep bedding or we are changing to spread a lot more on the pasture, there are implications on how each of these scenarios emit. So depending on how much work we are able to do, the information contributes to improving future work.
Thank you. So just to add to Prof, your question, that is why we have designed a Google form that will be shared on the GSAP platform. There are certain questions. We think that our team, we are not more than 20. We are not more than 20, but look at the number here. If we get more animal scientists to share their opinion on the areas that we did not have data, but we think that expert judgment is better than using a regional default factor. If you all input that, it will improve the emissions that we have. So it means that in our next reporting, your input will be incorporated and it will improve the greenhouse gases emissions. Thank you. Selassie.
Okay. Thank you. It was a good presentation, a great eye-opener. I have two questions. You suggested that measures should be put in place. I'll suggest that if you can maybe highlight those measures that should be put in place to help us reduce the emissions that will come in to assist us as a country. Then the other thing too is that from following up the earlier submission, because from what we heard yesterday, the population is more than what is being reported. And so I'll suggest that with this outcome or with this work done, if you can have some compelling reasons so that we meet the minister, because I know that this time around he has great interest in livestock production. So we justify reason for a proper census to be done. It will go a long way to help us so that these information can be accurate. Because I mean, I've been to places when you mention livestock population, it looks like people are not too sure of what is being churned out. And so with this, we can make a great way and let the minister get involved. Yeah. Thank you.
Doc, please kindly let me respond, then it comes to you. So your first question was to highlight some of the, yes, I did mention and explain at least one. I said that because we have a lot of browsers, and browsers contains tannins. So when the animals feed on it, the tannins protect the protein in the rumen, which is a plus for animal scientists or for animal production. But when it gets to the lower tract, not all the protein are released for digestion to benefit the animal. Some are lost through the feces and the urine, and they are a source of emission. So the browsers will reduce methane emission, enteric methane emission. But if we don't manage the waste, it will increase nitrous oxide emission in the dung and the urine. So if we have a system that the waste generated is more or less recycled by fertilizing it into the soil as quickly as possible, it will minimize the emission, and it will go a long way in supporting pasture development, especially natural pasture development. which will have good quality feed, high digestibility. And when fed, it will reduce methane. And because we are recycling it, the nitrous oxide emissions will also be lower. The next point is that during our stakeholder engagement, we invited the director of APD. He was with us. We invited some Ministry of Agric animal production staff. They were there. EPA staff were there. And then most public universities and research institutions, and even the chairman for transhumans, Dr. Opwanane, was invited. He was there. Following up again on, I think some question came up about what can we do. Currently, we are trying to source funds because my colleague highlighted the fact that we don't have data on transhumans. And before you are able to incorporate transhumans data, there should be consistency. It shouldn't be just 1 year data. Also, you have to categorize the cattle. They don't stay for good. So if we want to incorporate that into our greenhouse gas, in this greenhouse gas inventory, we omitted it because we didn't have their population from 1990 to 2022. Two, we didn't have any data that can suggest to us as to how we can segregate the category. But we have made an attempt, we have submitted a concept note, and it has been accepted. So that funding would concentrate on getting credible data for transhumans, which in the improvement, hopefully in the next 2 years when we are meeting again and there's an update, you hear that we have included transhumans. We'll go to Dr. Holy then. We have to. Okay. It's for Ghana. Okay, thank you. We didn't do with the bomb calorimeter, even though we have, LIPREC has a bomb calorimeter. Okay, but we didn't do that. IPCC have come up with equations that when you put the feed cooked protein, it will automatically calculate the digestibility and yes, it will estimate the digestibility and the gross energy. But that equation is based on work that has been done over the period of time. Not in Ghana. Yes. Okay. Thank you for your contribution. But to add to asking us whether we consulted other scientists, yes. In West Africa, Senegal has done it. So 2 consultants were assigned to us. One was from Senegal, and he is for Africa. Then another from New Zealand. So 2 of them assisted us. But in West Africa, it seems Senegal and Benin, they are the only ones who have done it. So Ghana is the 3rd. But in Africa, we also saw Zimbabwe. They did it in 2021. So these are very few countries in Africa. So Ghana may be the 4th or 5th to have done it in Africa. Okay. Okay. We are open for funding. Any institution that will fund us will do the work.
There's the issue of transparency and comparability. The work we do here is not supposed to be in isolation. We can have the best technologies to produce all kinds of data, but it should be possible for us to compare our output with other countries. That is how come the IPCC has come up with guidelines. So no matter where you are, there should be uniformity in everything you do, so that when they look at the emissions from Ghana, the efforts you are putting in here, you should be able to say that, yes, when we go to country B and they do similar things, you get similar results. So you can have the best techniques for doing this, but you need to conform with the lay down procedure. And that's how come we have to stick to some of those things.
So to add to what you said, I also asked the consultant a similar question. He told me that if we want to, we have done some research over a period of time, and we want IPCC to take into consideration in improving greenhouse gases, we have to submit that report to IPCC. It will go under review. If it's accepted, it will be incorporated into maybe for West Africa or for Ghana. But it's a long process, and you need to have provided data consistently for probably 10 years or more. So we'll get there one day. Okay, I think that we can continue to discuss. So thank you very much for listening. Thank you.
Thank you. Thank you very much, Dr. Sako and the team. It's already 10:47. I don't know whether we have to take a snack break, and then we come out with a breakout section. Oh, today the agriculture troop didn't come. So anyone who is going to have a presentation, please, if you go to the back here, there's a room here. You can submit your slides. You can submit your slides for them to keep for the presentation. We are going to use 2 rooms, so it's going to occur concurrently. We will use the main room, and then there's a syndicate room just when you go out, just here. So those are the rooms that we are going to use for the presentations. For the students, we are going to have some form of competition. So if you are presenting and want to take part in the competition, you can bring your name to us so that we will include you in the competition. Otherwise, we will consider all presentations as normal presentations, and input will be given where necessary for improvement in your research work. So if you want to enter into the student competition, kindly see me and then give me your title and then your name. We have undergraduate category and then postgraduate category. So I think with the numbers that we have received so far, we are going to host the monogastric presentation in this hall. And then the ruminant session will be moved to the syndicate hall. Because we are combining all the presentations together, we will have to have maybe one or more than one chair for the session. Or we can have chairs in 10. So if maybe you handle some presentation for a while and you are tired, another person can take over. So for monogastrics, we are looking at Dr. Hagan, B.A. Hagan, as a chair. We also have Prof. Wala Akuti. And then we have Dr. Fritz R.K. Bonsu. And then we have Prof. Julius Hagen, as well as Prof. Michael Boaten. These were to have different sections of the scientific section, but because we are conducting all of them together, they have to decide who will chair. They should co-chair. All right. Then for ruminants, we have Dr. Alasan Osman. Oh, only one person. Maybe you have to move. Dr. Egan, do you want to move to the ruminants, or you want to remain here? You have only one person chairing the ruminant section. You want to move? Ruminants, okay, thank you. Then we have micro livestock and others. Dr. Peter Siedu. Okay, so the ruminants and micro livestock, we will move you to the syndicate room. And then the monogastrics will stay here. So please, we are still collecting the slides for presentation. We want to do everything and then put them on the computer before we start so that people will not be coming in and out to bring their presentation. So if you have not done that, can you do that for us?
Lab.
A quick one. We also have poster presentations. So if you brought a poster, the boards are outside. Kindly go locate a place that you want to fix it and then fix your poster there. We also have maybe, you let me hold on. Hussein, SMA. Is he around? Then we also have Abiba T. Effect of partially replacing soybean meal with desert date seed cake on good performance and blood profiles of guinea pig. Who will be presenting? You are the one presenting. You are the one presenting. Okay, all right, then you can come.
Thank you, Dr. Adam. Hello. Hello. Okay, so we have 10 minutes for presentation. We have 10 minutes for presentation and 5 minutes for interactions. Can you see us? Okay, let's do 10 minutes. Then 5 minutes for interaction, or 12 3. So we are doing 10 minutes of presentation and 3 minutes of interaction so that we can do as many presentations as possible. Okay. So this one is missing. The technical team, can you help us? Technical team. Okay, so Dr. Agolizi, you can start now.
Good morning. Okay. I'm presenting on behalf of a team, and the topic is effect of partially replacing soybean meal with desert date meal, seed meal on growth performance and blood profile of guinea pigs. Can you hear? Okay. All right. So when it comes to animal production, I think yesterday most of the presenters mentioned feeding as a major challenge. So feed and feeding is a major challenge when it comes to livestock production, especially in the northern part of the country, northern Ghana, during the dry season, having access to quality feed during the dry season is a major challenge. And when you also look at the prices of soya, the granules, they are also going up. I think beginning of this year, soya bean meal, 50 kg was being sold around 600 Ghana cedis in the Upper East region. So that is a major challenge for us. And this soya bean meal too, you see that we are also in competition, human livestock competition. We are using the granules for granule cake. We are using the soya. They use it to prepare dawa dawa and a lot of things. So at least the competition is very high. And there is the need for us to address these challenges. And one of it is we looking at the potentials of using the desert date seed meal, which is available. And research shows that the crude protein is around 20 to 30%. And that is the raw one. So in our case, when you look at northern Ghana, these trees, they are desert plants, and they are in abundance. They are there. When you look at the Savannah region, you take the northern region, Upper West, Upper East, they are there in abundance. But the major issue is that we have not done studies on them. We have not made good use of the seeds. We only know of the medicinal benefits of the leaves, the bark, but we are not using the seed itself. So this research was just to focus on evaluating the nutritional benefits of it. That's why we decided to use the guinea pigs as our initial research to get our results. So the research was conducted in Bolgatanga Technical University in the Department of Ecological Agriculture and Livestock Units. We adopted completely randomized design system. So we had 4 treatments. We had the control, that is soya bean meal only. We had 5% of the desert date seed meal, 10% and 15% inclusion levels. So we harvested the seeds from the plant, and as you can see, we harvested it there. Then we have to crack to remove the kernels. From there, we use the mechanical press to press the oil out, and then we use the meal to prepare the feed. And these are the various ingredients that we use. We use the wheat bran, soya, and then we decided to use 5%, 10%, and then 15% to prepare the feeds. And we offered it to the guinea pigs. So we used 20 guinea pigs, 5 per treatment, then 1 per cage, and it was replicated 5 times. Sorry, I made it 4 there. Then each of them, we offered them 20 grams of the feed per day for 84 days. That is around 3 months they were in the experiment. So we look at growth performance. We looked at the nutrients, digestibility, and then we look at the blood parameters, which is the hematological parameters. So we use the GenStat version 12 for the analysis, and the means were separated at 5% significant levels. So this is the resource. So there is the desert date meal. You can see the crude protein. With the raw, I have not projected that one, but when you look at the raw where we did not process the seed, the crude protein was around 30%. But with the meal, it's around 44%, which was just getting closer to the soya. Then we had the crude fat, crude fiber, and all that, which was equally good, that we can exploit its relevance in the animal industry. So we look at dry matter intake. When you look at it, there was no significant differences. They were similar when you look at all the treatment. Then from there, we move on. Then we look at the crude protein intake, which was also similar across. But when you come to that of the dry matter, digestible dry matter, then you see significant increase in it. So that of the 15%, we had a higher dry matter digestibility there. Then we come to the digestible crude protein. That one too, we had a higher percentage or digestibility coefficients for the T3, which is the 15%. Okay. Then because we were looking at it, we didn't get any literature somewhere to back our findings, because we search and look at it. They have not used the male, they only use the raw seed for that. But looking at it, they reported similar ones. That was just also closer to what we had. Then when we come to the initial weight, which we just did it at random, and we used the initial weight, which was not that different from each other. Then we look at the final weight, the weight gain, then average daily weight gain, feed conversion ratio. They were all similar across the treatment. But you see, though they were similar, but when you look at the daily weight gain or the final weight gain, you can see some marginal increases in them as the levels increase, but they were not significant. So that shows that we can actually use the desert date seed meal to replace the soya bean meal at a certain level. Then we say get maximum performance. Then this is the interesting area where looking at the blood, yes, there was some marginal increases in the weights which were not significant. But when it comes to the blood, you see, when you look at the hemoglobin levels, looking at it, the control, as the levels increases, then you see the hemoglobin levels also going down, which were far, far below the average hemoglobin for guinea pigs. It ranges from 12 to 13. But you can see that these ones were far below it. And that means that it has negative effects on the blood. Then we look at the cell pulse volume. Similar trend. You look at the red blood cells. It was also there. The white blood cells, all of them, significant reduction in them. And this one calls for further studies, because this is the initial one, and we cannot conclude unless we repeat it several times so that we can actually explore the potentials of this wild plant. So our conclusion, feeding guinea pigs with the desert date seed meal had significant effects on the blood profile. So we recommend that we carry out further studies so that we can explore the potentials, so that at least we can use the oil and also use the meal to improve on our livestock production, so that instead of us we relying on soya bean meal all the time, at least that area there we can make good use of the plant. Thank you. Yes. Yes. Okay. I think the slides are not projected. Well, we had the T0. That one is fully soya. There is soya bean meal in it. Yes.
The effect on the blood, I am thinking it could have been a contributory factor from potential phytochemicals. Have you done anything on that?
I've submitted some of the samples to. I think I gave some to Science and Tech here. I'm here to get the report, and then a sample to UCC. The technician there has not given me the report yet.
Okay.
Yes.
Then
but
apart
I'm
from
waiting
that,
for that.
are you thinking of considering the costs? Because we are so much interested in the cost of the material. If we can actually have an idea of the cost relative to the soya bean you are trying to replace, then we can say it is a viable alternative. What's your comment on that?
Yes, I think in our future research, we'll be looking at the cost involved. But because this one was just the initial, we're looking at the potentials of it. Once it works, then we can conduct future research to now look at the cost and several factors.
Listening to you, I got the impression that increasing the amount of your test meal was having adverse effects on the blood profile qualities of guinea fowls. But I don't think you were succinctly clear about that. It's as if you were waffling around that. Anyway, thank you.
Yes. I think with the figures I projected, I was very clear on that. I said it had effect on it, which was very negative. And I said there is a need for us to do further research, but we cannot conclude. Because looking at it, the performance in terms of the growth, it was okay. But when it comes to the blood aspect, that is where the challenge is. And because we did not also encounter any mortality during the experiment. So we are looking at doing more research. Then we can now have a stronger conclusion. Thank you.
Point, but later you were saying 5%, 10%, 15%. So I'm kind of confused.
Okay. So the 0.5, the 1, and then I was using the percentages because when you look at it, the inclusion level within the soya and that of the desert date meal, that's why I'm using that 15 and then those percentages. But in terms of the quantity, it was 0.51 and those
0.5
1 and then 1.5. But
percent.
no, yes,
fish.
percent for the entire 100%. But when within the soya itself, where we were replacing, that is where those percentages came from.
Thank you very much.
Okay.
Thank you.
Thank
Please, we can give him a round of applause. So we take the next presenter, Toby and Mohammed. Effects of sodium hydroxide treated false yam tuber meal on the growth performance of winner rabbits. Okay, I think he's not here. We will take Dr. Butri. Okay. So he's going to give us a presentation on the topic genetic diversity, population structure, and phylogenetic relationship of rabbits. Of rabbit populations in Ghana using micro-satellite markers, a systematic review.
Good morning. My name is Richard Asante Botri. A postgraduate student, University of Cape Coast. I am presenting on genetic diversity, population structure, and phylogenetic relationships of rabbit populations in Africa using molecular markers. Yesterday, when our keynote speaker was speaking during his presentation, he emphasized that for Ghana to adopt AI in livestock production, there is urgent need for data for us to properly match up with the Western world. Currently, there's no available data on rabbit populations in Ghana. I'm talking about molecular data. So in our quest to characterize rabbit populations in Ghana using molecular markers, we have conducted this systematic review and meta-analysis to find out what other African countries have done. They have applied molecular markers to characterize their rabbit populations, to know their genetic status in a way to design a breeding program and also conserve the rabbit populations. So we followed PRISMA guidelines and we set up inclusion and exclusion criteria. We conducted our search in some databases, and our search resulted in 14 studies that we used as baseline for our systematic review. So this is the characteristics of the studies that were involved in our systematic review. We found out that 6 African countries so far, they have used molecular markers to characterize their rabbit populations, and they are Egypt, Nigeria, Kenya, Algeria, Tunisia, and South Africa. And these 6 African countries, they exhibit 7 different agroecological zones or biome types. So we can see deserts, we have 7 studies conducted over there. Savanna and grasslands, 2 studies, forest, 1 study, semi-arid, 1 study, and mountainous regions, one study. The higher number of studies conducted in the desert zone is attributed to Egypt, which is found to be the leading producer of rabbit meat in Africa. And even in the world, they are number 3. The 14 studies also utilized 3 different marker types. So the first one, 7 of the studies used SSR, that is microsatellite markers, and 1 of the studies used mitochondrial DNA, and the last one used SNP markers. The sample sizes range from 9 to 410 rabbits in all. And the markers, the SSR markers that were used for each of the studies, it ranged from 4 to 85 molecular markers. So in a way for the authors to identify the genetic diversity of the rabbit populations, they estimated the expected heterozygosity and also the observed heterozygosity of the populations. And when we talk about expected heterozygosity, it refers to the heterozygotes in the population under Hardy-Weinberg's equilibrium. And in population genetics, when we talk about Hardy-Weinberg's equilibrium, we are talking about a population where there is random mating, the population is relatively large, there's no mutation within the population, and there's no gene flow, there's no migration of exogenous genes into the population or moving samples from the population outside. So that is expected heterozygosity. And they also measured the observed heterozygosity. This represents the actual heterozygotes within the populations when they were genotyped. So as we can see, the expected heterozygosity was higher than the observed heterozygosity. Under Hardy-Weinberg equilibrium, HE is supposed to be equal to HO. So any deviation from Hardy-Weinberg equilibrium is what leads to inbreeding coefficients. So here we can see that rabbit populations within this biome type, savanna and grasslands, their observed heterozygosity is lower than what is expected. And it suggests that there is a deviation from Hardy-Weinberg's equilibrium. It can be attributed to maybe migration of some of the populations outside the zone, which resulted in the decrease in the observed heterozygosity. And a decrease in observed heterozygosity also results in inbreeding coefficient or inbreeding levels. We can see that inbreeding level here is highest among all the agroecological zones. And if there's an increase in inbreeding levels, it results in decrease in fitness level or decrease in vigor, which can affect the population. And in the course of time, if proper conservation or breeding system is not implemented, it will lead to extinction of the whole population. So we also determine the genetic diversity of the rabbit populations by the biome types. So the colors The blue color represents the expected heterozygosity. The yellow, orange is the HO, observed heterozygosity, and the yellow represents inbreeding levels. So each of the biome types here represents each of the African countries. So these are the 14 studies that were used for the analysis. And in Egypt, 7 studies were conducted. So we can see that some of the African countries, they have higher expected heterozygosity than what is observed. And the inbreeding levels is also different. It varies across each of the African countries. So here, South Africa, this is the level of their expected heterozygosity, and this is what is observed when the population was genotyped, and the yellow represent their level of inbreeding. So we can infer that rabbit populations in Nigeria, according to this study, is lower than what is observed in South Africa. And when you compare this, each of the bar represents each study. So in Egypt, this study, their inbreeding levels is higher than what is lower than what is observed in Kenya. So this is a guide for Ghana if we also want to know the genetic status of our rabbit populations. We have to use molecular markers and characterize them so that we will be able to design a breeding program for it. Conserving and breeding implications. So we can maintain connectivity of the habitats in a way to reduce the inbreeding levels of the populations. We can protect the populations with unique genetic compositions. We can address high inbreeding levels in some of the agroecological zones that I spoke about. And the studies shows that there are significant variations in genetic diversity patterns across different African countries that were affected by their agroecological zones. And savanna and grassland was observed to have the highest genetic diversity, whilst those in the mountainous areas, they recorded the lowest genetic diversity. That is, their populations are susceptible to genetic erosion. They used rabbit populations in the wild, and they reported that some of the environmental factors, such as the mountains in the area, led to population subdivisions. The populations were divided into subgroups. And so according to Hardy Wimbergs, if the populations are smaller, it means
one more minute.
Mating will be non-random, and it can affect the inbreeding levels. There's also limited gene flow between populations, and this indicates strong population structure. Molecular marker types and biomes significantly influence genetic estimates. And lastly, there's evidence of inbreeding in multiple populations in most of the African countries that we studied. And so there's an urgent need for Ghana to conduct characterization of our rabbit populations using molecular markers so that we can design a proper breeding for.
Thank you very much, Mr. Butri. The floor is open for interaction. But before then, I will ask a question. You had indicated that you made a statement that when there is a deviation in expected heterozygosity, Like when there's a difference between expected heterozygosity and observed heterozygosity, it's inbreeding.
I mentioned that under Hardy-Weinberg's equilibrium, there should be there's no mutation. There are assumptions.
Yeah, we know that. Yeah, but that statement, like I felt you have expected and observed. You are expecting everything to be the same so that there wouldn't be any inbreeding. But what you presented, most of them, the observed heterozygosity was lower than the expected. But there are instances where you can have higher observed heterozygosity.
Yes.
Which would not be inbreeding. That is what we expect, so that there will be what? Diversification or diversity.
Yes.
And so that statement was probably not right.
Okay.
Yes.
Right, thank you. I need you to clarify something for me. The genetic diversity, you did this work in Ghana, right? Uh-huh. And then I do know in Ghana we have a number of breeds of rabbits. Is that not so? Uh-huh. So, did you do your work on a specific breed? Or you did it, what I'm trying to ask is it within the breed or across? Because if it is across and you are having diversity, then it is no surprise. But if it is within one breed you are looking at, for example, New Zealand white, then you are measuring the genetic diversity. That would give us a clue. So please, you need to clarify that for me. Thank you.
For now, because we have not used molecular markers to determine the genetic status of our populations, we cannot say that this is a New Zealand white. Because what the farmers are doing are crossbreeding. So you will have a New Zealand white, which will later, and it will give you a chinchilla or Angora or any other breed. So until molecular studies is done to confirm the genetic status of the populations we have, we cannot see we have a breed in Ghana now. So we use about 5 databases, and we use, like you mentioned, Web of Science, PubMed. We use Google Scholar. We use Cochrane and other databases.
So please, the announcement is that we are going out for our snack break. When we come back, we'll continue with our presentations. And we'll have a presentation from Makanjola. Is he here? The topic is dietary effects of acidifier and multi-enzyme supplementation on growth performance and back fat thickness of grower pigs. Okay. The next one is Eje Hinaku. Eje Hinaku is here. Okay. So I think when we come back, we will take a presentation from Eje Hinaku. Which we're using only 10 minutes. Thank you.
laying capacity. But they could also benefit in egg production and quality when administered with the noni fruits extracts. Then there's also a problem with storage of eggs. Most poultry farmers mainly store their eggs in open ventilated rooms, resulting in increased egg losses over time if they are not able to sell it early or when there is a glut. Thus, investigating noni fruit extracts can provide empirical data for taking informed decisions, improve bird productivity and farmer profitability, and also promote sustainable agricultural practices. Administering noni fruit extracts in drinking water may not improve egg quality and production performance, as well as extend the shelf life of eggs, or may not have dose-dependent and physiological stage effects. These were the hypotheses tested in this study. And the objective, therefore, was to evaluate the effect of varying concentrations of noni fruit extracts on egg laying performance and egg quality characteristics in the bovine brown hens, and also to assess the effect of the fruit extracts on the extension of shelf life of the eggs. Okay. The data collected includes weekly individual body weights, daily feed and water intake, egg mass, end-day egg production, feed conversion ratio, etc. And 2 eggs were collected at weeks 22, 30, and 48 to represent the physiological stages. And also, 2 eggs per replicate were taken per replicate per treatment. That's 30 eggs were used to evaluate the effect of the levels of the noni fruit extracts and also on the shelf life. The internal egg quality, that's the albumin height, the Hall unit, yolk index, and yolk color, as well as the estimated eggshell thickness were also measured. And the models used to estimate the parameter variables in the study are as shown in models 1 and 2. Because of time, I'll not go through the the indices. The general linear model in GenStat was used to analyze the models, and significantly different means were separated using the student Newman-Kuhl's tests in the same software. When you look at the results, you could see over here that the birds on the noni fruit extracts had significantly higher values. This may be due to the bioactive components in the noni fruit extracts. And these bioactive nutrients are usually referred to as the nutraceutical components of the noni fruits extracts, which are beneficial to the birds. And it's made up of the flavonoids, the phenolic acids, there are vitamins. We also have amino acids, etc. And these may have contributed to the increased egg mass that we see over here, the high egg production, the improved feed conversion ratio, and the improved net feed efficiency index. The effect of physiological stage also usually declines with increase in age. But here you could see that for the egg mass, it increases with age because of the tendency for the bird to lay bigger eggs, and also the hen day egg production declined from peak to late lay due to reproductive, age-related reproductive, how do you call it? The age, age, sorry. Let me see. Yes, age-related reproductive issues. Yeah, the word issues escaped me. So that may have accounted for the decline of the egg production, hen day egg production from peak lay to late lay. When you look at the egg quality, the birds on the noni fruit extracts had better egg quality parameters. That's the albumin height, Hall unit, estimated eggshell thickness, yolk index, and yolk color. And these may have been due to the effect of the bioactive components in the noni on the oviducts, albumin secreting glands, and also the protein synthesis glands of the oviducts. And also the improved capacity of mobilization of calcium to produce thicker eggshells. For yolk, okay, that will be for the next one. The effect of physiological stage also declines with the quality of the eggs declines with physiological stage. And this, declines with physiological stage. And yeah, it generally declines. These results were similar to that of Peric. And for yolk color, with physiological stage, it improves due to the increased xanthophyll metabolism efficiency of the hen with age. During storage, the birds on the noni fruit extracts lost less water. The water loss was reduced. And this may have been due to the improved calcium metabolism of the effect of the noni fruit juice, causing the eggs produced by the birds on the noni fruit juice to have thicker eggshells and less porous eggshells. But when you take the egg quality, you could see that all the parameters, both the control and those on the noni fruit juice, reduced with storage time. But that of the birds on noni fruit juice, the decline was lower or less than that of the control. And this may be due to the bioactive effects of the noni fruit juice on especially the Hall unit and the yolk index. Another reason could also be that the noni fruit, the bioactive components of the noni fruit juice also, another reason for the reduction in the yolk index is that the yolks of the eggs were, when they are bigger, the yolk loses its, becomes flatter. It loses its oval shape and becomes flatter, hence reducing the Hall unit and the yolk index. So in conclusion, the noni fruits extract improved the egg mass hen-day egg production, feed conversion ratio, and the net feed efficiency index, as well as improve the indicators of the egg yolk quality, which are the albumin height, whole units, yolk index, and the estimated eggshell thickness. Thus, administering noni fruit juice reduced the rate of degradation of stored eggs in terms of moisture loss and also egg freshness. The 40 milligram noni fruit extracts administered in drinking water at week 16 achieved the most desirable results. There were no signs of diminishing returns, so we recommend that we explore the effects of varying doses of noni fruit juice beyond the 40 milligram per meal concentration to determine the best range for maximizing health benefits and production performance without negative effects. And also, we need to investigate the possible interactions the noni fruit extract supplementation could have with other feed components and medications on the overall health, reproductive performance, and longevity of the hens at different physiological stages. Thank you for your attention.
Thank you very much. Please, yes, Dr. Zano.
Thank you very much. Yeah, thank you for the nice presentation. I have a few questions. You said your hypothesis is that you don't expect to see any influence of the extract. Why? Because you have set out to investigate the usefulness of the extract. So why will you choose such a hypothesis? And then the other one is you were comparing 3 phases of the production, early lay, and other stages. Why would you want to compare? Because you expect that as the animal ages, egg production will improve. So is this scientific to want to compare 3 different phases? And then you need to check your FCR. I don't know whether you got the calculator, you need to check it. So the hypothesis, the physiological stages, and then the FCR.
Okay. Then the first question, can you go over it again? Sorry. The hypothesis. Okay. Usually, to test hypothesis, we state the null hypothesis. And when the experiment goes otherwise, then we accept the alternative. So the alternative was accepted in this case. The null hypothesis said that the noni juice may not have those effects that we were expecting, but we had the effects. So we accepted the null alternative hypothesis. I don't know if there's any other way to explain, but that's the null hypothesis. And it's usually expressed in the negative. Okay. Alternate. Yeah, sorry. Oh. Okay, so we rejected the null hypothesis. Thank you for the correction.
One more. Okay, which was
the physiological stages.
The physiological stages.
Okay. Normally, the eggs decline in quality with physiological stage, especially the albumin and the yolk index. And this is because as the hens grow older, they lay bigger eggs. And the yolk loses its ovoid shape and flattens out because of the size. So the yolk index drops, and the Hall unit also drops. So the egg quality declines with age, even for freshly laid eggs. And this was observed by Perrick. And okay, yes, yes, yes. Okay, the extract contributed to it.
How do you know?
I know because with the results on the screen right now, no, not this one. The effect, when we tested the effect of the noni fruit extracts, the bears on the 40 milligrams had bigger eggs, hence bigger egg mass. And that of the control were lower. So it means that the noni fruit juice had some effect over the significant effect on the size.
Okay, we'll take one more question or contribution. Okay.
Okay, thank you, sir. I just wanted to find out if you did some chemical analysis of the noni fruit to find out what it could contain to be contributing significantly to especially the egg performance.
Yes,
so that we
I did.
could recommend that to farmers.
Yes, I did. And before I used the noni fruit juice, I did the extraction over time, over a 12-week period. So I realized that on the 8th week, the bioactive components of the noni juice were, fruit extracts were higher in terms of the vitamins, especially vitamin C, and the other antioxidant components, like the flavonoids and the phenolics. They were higher at that point. And this was due to the activity of the fermenting microorganisms, like gluconobacter and acetobacter. They tend to convert the flavonoids into more potent flavonoids, like quercetin and camphorol in the fruit extract as the fermentation goes on.
Okay, thank you very much. Please, let's clap
Thank
for
you.
him. So our next presenter is Dr. Kofi. So he's going to give a presentation on the topic Complete Reproductive Hormonal Profile Across Laying Stages in Indigenous Chickens.
you, Chair. Mr. Chairman, distinguished colleagues, professors here, all protocols duly acknowledged. I'm glad to be here to present on the topic, complete hormonal profile across laying stages in indigenous chicken. Indigenous chicken represents valuable resource with unique reproductive characteristics and adaptive traits. The reproductive performance of these indigenous chicken is orchestrated by the hypothalamic pituitary ovarian axis through coordinated actions of key hormones, including gonadotrophin hormones and then the reproductive steroids. Despite these domestic chicken being constituting 80% in the chicken population in developing countries, comprehensive hormonal profiling across distinct laying stages remain underexploited. Therefore, there is the need to investigate the effect of the assay of these reproductive hormones on the laying performance of this indigenous chicken. This experiment was conducted in Amstead, that's the Kentapia Minka University of Skill Training, Entrepreneurial Development, Animal Science Department, Poultry Unit, and 90, we use CRD as a design, that's completely randomized design, and 90 indigenous chicken of different age categories, of the same age, and categorized into 3 groups. That is the early laying stage, pre-laying, early laying, and then late laying stage. The blood were collected from sampled indigenous chicken and were subject to analysis in accordance with the manufacturer manual. The reproductive indices measured include dairy egg production, weekly egg weight measurement, and then the clutch pattern indices. The statistical analysis used was SPSS using ANOVA to conduct the analysis. Pearson correlation was done to assess the relationship among the indices assessed. Results and discussion. The follicle-stimulated hormone in early hens had the peak at the pre-laying stage, followed by the early laying, and then the late laying in descending order. And this is supported by the literature. This is done to enhance follicular wave or recruitment, where the level during sexual maturation promote initial follicular development with the subsequent decline at the later stages. With the luteinizing hormone concentration, there was a biphasic pattern with the moderate level at the early pre-laying stage, and then with the late laying stage, with that of the early laying scoring the intermediary with the highest or the peak amount. And this is where the problem is. In commercial production, the level of luteinizing hormone should be maintained so that egg production follows like that. But in the local chicken, in the late laying stage, it declines. Hence, it has effect on the laying persistency. Therefore, the reduced laying stage as we observe in this local chicken. Estradiol concentration was also higher, or recorded the highest titer in the pre-laying stage, with the late laying scoring the lowest. And this too has implication on the laying performance, as higher estradiol concentration during pre-laying stage confirm the pivotal role in what the reproductive tract. And as it reduces at the late laying stage, the laying persistency will be influenced negatively. Progesterone concentration, however, were similar within the pre and then early laying stage. By increase in the late laying stage, which has the potential of what? Stimulating broodiness and reduce laying persistence. And this means that if you're able to manage these levels of progesterone at the late laying stage, there's a tendency of what? Enhancing their laying period. Prolactin was also higher at the laying stage, and prolactin is the nest building or a broodiness hormone. So when it is higher at the late laying stage, it will trigger these local birds to sit on the cloth of egg deflate instead of continuing the laying performance. Here too, an analog could be administered to reduce the level at the late laying stage, which can have a potential of extending the laying performance. Reproductive performance across laying stage was also assessed, and the age of first egg lay was between 18 to 23 weeks, averaging 20 weeks in the local indigenous birds. This is becoming similar to our commercial birds and this is as a result of the layer mash that we use to feed these birds that might have improved upon their average laying performance in this study. Yeah, there were correlation assessment done, and we realized that there were positive correlation association with the hormonal assessed, the hormones assessed, and then the reproductive indices that were measured. So you could see that there are positive correlation between laying rate and that of follicle-stimulated hormone, luteinizing hormone, estradiol, with negative correlation in progesterone and estradiol. And this really determines it measures the relationship between these indices. And when we take luteinizing hormone into consideration, we could see that the percentage contribution there, or the strength of association, is around 0.72%. What are the implications for this indigenous chicken management? The distinct hormonal profile identified in this study have significant implication for indigenous chicken management, physiological enhancement, and breeding protocols that could be used to select for the birds that have that potential of what producing at lengthier laying period, or selecting for birds that can really maintain their hormonal concentration at a point of extending their reproductive performance. The hormonal data also provide.
Please wrap up.
Okay. The baseline information for identifying birds with the superior reproductive species. And in conclusion, the indigenous chicken exhibit distinct reproductive hormonal profile across laying stage, different from the commercial ones. We also realize that the progesterone, the follicle stimulating hormone, biphasic luteinizing hormone concentration, A-related estradiol decreases established baseline data for indigenous chicken reproduction management. Hormone performance correlation provide novel insight into reproductive regulation in indigenous chicken. There is a need for future direction, then investigation on molecular mechanism underlying hormonal.
Thank you very much, Doc.
Thank you.
We'll read it. Okay, thank you.
All right.
Okay, the floor is open for, I'll take 2 questions.
Okay. Thank you, Dr. Kofi. My interest is with the negative correlation between the FSH and then the egg weight, and also the prolactin levels at the later stage. With the correlation, do you think it could be more of nutritional? And that is a major problem with indigenous chicken, the way we keep them. And then you mentioned the prolactin levels being high, encouraging broodiness. I wanted you to highlight more on the solution that you gave, that we can use this to reduce the broodiness and then let them continue to be in egg production. Thank you.
Okay, thank you, Prof. Yeah, for the negative correlation between progesterone and then the laying performance, the FSH, okay. All right. The negative correlation occurred between FSH and that of the egg weight and then the interclutch interval. Why does that happen? Once the FSH is increasing, then it means that the interclutch interval will be reducing. That's the implication. And what happens? The FSH should be there to stimulate follicular wave. And when the follicular wave is established, the concentration must reduce. By linking your question with nutrition, nutrition might be adequate to support these animals to produce the adequate quantities of these hormones to support their reproduction indices. However, these chickens are normally maintained on a form of nutrition that is not adequately taken care of as we do in the commercial poultry. So per this research, we realized that even their level of laying at the first time decreased, which is related to that of the commercial chicken duration, around 20 weeks. However, the range was between 18 to 23 weeks. Perhaps it was because we put them on the layer diet that might have improved upon that. There is a study that was conducted by Lee et al. When he maintained these birds on their normal roaming attitude, the scavenging, and the laying age at first laying was around 22 to 27 weeks, with average being 24 weeks. It means that the nutrition really play a role in their performers. Thank you.
Dietary aquatic fen intervention enhances growth dynamics in broilers. Insight from meta-analysis. This is okay, I think he or she is not here. Do we have Akowa? Detection of bacteria and fungi contamination in table eggs. Akowa. Okay. Nati. Assessing consumer preference for egg quality. Okay. Mr. Kwe. Okay. So we'll take the next presentation from Mr. Kwe. Nutritional value of processed sorghum grain varieties. Hello. Can you hear me now? Technical team. So we're going to listen to Mr. Kwe. His topic is nutritional value of processed sorghum grain varieties for food utilized broiler feed ingredients.
Good afternoon, Chairman, revered professors, researchers, ladies and gentlemen. So my name is Bernard Kwe, and this afternoon I'm here to share some excerpts of an ongoing work, but this particular one is one of the specific objectives to explore the nutritional potential value of processed sorghum grains, and particularly it looks at the nutritional and anti-nutritional composition of these processed sorghum varieties. The plan of this is to look at using this as a bold attempt to replace maize as an energy resource in broiler diets. So this will be the outline of our presentation. So to introduce this presentation, it is a fact that is established that the element of feeding and then the nutritional demands of broilers continues to receive constant critical attention. And a lot of these has been towards where researchers are looking at major trends that would help to alleviate these nutritional concerns. But the efforts that we are putting seems far from over, because day in, day out, we keep having some of these researchers that comes up. Particularly, locally in Ghana, we rely principally on the maize for our broiler or poultry diets. And the issue with using the maize continuously has been mentioned by the fact that it is a staple feed ingredient, and in most local communities in Ghana, it's actually facing competition between man and then livestock. Particularly when we take the maize, it's highly expensive because of, obvious reasons such as cost of production and even environmental issues. Maize also is unstably priced. I can recall this year alone, we may have had about 3 or 4 price windows of maize. And in a lot of the cases, we even have to depend on importation to get it backed up when there are shortages. So sorghum looks like a suitable alternative when it comes to energy source, because principally or worldwide is about the 5th most important cereal after maize, rice, wheat, and barley. And sorghum production in Ghana is on the high, but particularly in 2021, about 300,000 plus metric tons of sorghum had been produced here in Ghana. But the issue is it's not extensively being utilized by humans in Ghana. And when we take the reason why sorghum has not been fully explored, the idea of presence of tannins makes this the reason why it's not been fully explored. The reason being high tannins in feed tends to affect feed intake, palatability, and even compromise digestibility of the feed. When we take the NRC reference, it particularly has reported ME values or metabolizable energy values of sorghum being close to that of maize, and even the crude protein slightly above that of maize. Hence, it's essential that we reevaluate and then explore sorghum and then the locally available varieties. So the objective, like I said, is part of a major work that looks at exploring the nutritional value of different varieties of sorghum here in Ghana, particularly the white and then the brown sorghum maize. But this phase is just a preliminary stage that looks at using efficient mitigation strategies that will reduce anti-nutrients in there, as well as improve the nutritional value of sorghum before it moves to the next stage of it being used in feeding trial. So to our materials and methods, we have applied common processing methods that could actually be replicated in the industry of soaking and then grain popping. That is, we applied heat. And these has been set out in a factorial design. So this is just a picture depicting some the processing techniques that had been adopted by soaking and then grain popping. These were the experimental treatments and how they were actually designated in this phase of the work. Some series of nutritional and anti-nutritional analysis had been conducted. For the nutritional analysis and fiber analysis, the near-infrared spectral reflectance spectroscopy had been employed to look at the nutritional and fiber content of this. And then some anti-nutrients have also been analyzed. We have an array of them, so for the sake of time, I'm just going to present just a few of these results. Here we have the NIR being used to undertake the nutritional analysis of the sorghum grain varieties that have been processed by soaking, as well as drying, as well as grain popping. data that we collected had been subjected to analysis of variance using the GLM in the Minitab. So I'll just spend a little more time. There is a lot here that I'm going to be rolling, but the results that will be rolling are just going to be presented results of interaction between the varieties and the various processing that has been employed in here. So here we'll see that there is practically significant differences across all of the approximate parameters that has been measured when the sorghum varieties were soaked for both varieties of sorghum, that is the white and then the brown sorghum, with increasing time. And if we look at the values that have been reported, the ranges of values are very much close to what the NRC has actually reported, and in a lot of the cases, they are slightly above what has been reported in comparison with maize. And it tells us that the NIR gives us a lot more precision when it comes to analyzing some of these nutritional assays. Proximate composition as well for the pulp grain also showed significant differences across all of the treatments, all of the parameters that were actually assayed for, again with the same preamble, comparing to what the NRC has actually reported. The values are very close to that of sorghum, and then even in cases more than that of maize. Amino acid profile, we had a long list of essential amino acid profile. Quite a number of them were insignificant, but particularly when we look at leucine and then the total amino acid profile, we had significant differences. And these, when we look at the values, were also close to that which was reported by the NRC and for sorghum, and then more than that of maize. Same happened, we see the same trend for the pulp sorghum grain varieties. We looked also at some anti-nutritional factors to see how these processes of sorghum over time, that is 0, 24 hours, 48 hours, and 72 hours, the impact of it on the presence of these anti-nutritional factors. And we could clearly see also that there were significant differences for all of these anti-nutritional factors that were present, which we saw qualitatively: tannins, flavonoids, total phenols, phytates, as well as oxalates. And these values that were actually reported goes to confirm the fact that whilst you increase soaking time, as reported by Monda 2002, soaking has got a capacity or tendency to reduce the anti-nutritional factors in there. Pulping as well showed a similar trend, but what happened with the pulping of the grains was that whilst we pulped and applied heat, these anti-nutritional factors tended to increase a lot more. So in conclusion, the approximate composition, amino acids, mineral elements, well, I don't have that here, but we did also mineral elements, anti-nutrients, have shown that sorghum could actually be a suitable alternative that we need to explore, but this should be done with processing to be able to mitigate the issue of anti-nutrients, that of tannins. And then soaking compared to be a more convenient method of managing these anti-nutrients. There's a third method that we are doing with fermentation, but the result is not ready yet. So our recommendation is that we should look at some alternative mitigation techniques to help us to be able to also address the issue of anti-nutrients, and then looked at the feeding value in the field. Thank you very much.
Thank you very much, Mr. Kui. So I'll take some questions. Yes, I'll take, then I'll come
I have three very simple practical questions. The first one is, why would you think of replacing maize with sorghum in Ghana? The second one is how much maize are we talking about when it comes to feeding, say, chickens in Ghana? And the third thing is, if you could replace sorghum with maize, what would happen to sorghum in this country?
Prof, so let me take it from, thank you very much for the question. Let me take it from the third question, which, what will happen to sorghum? Well, what will happen to sorghum? I would rather want to look at what would happen to maize, but what will happen to sorghum is the fact that sorghum also comes to be a good alternative, but our competition for maize is going to drop so that we could have a shared burden for maize and then sorghum. And then how much of maize are we looking at? Well, I mean, that is dependent for every feed formulation, but particularly for a lot of these are broiler feeds, then we are looking at about 55 to about 60% of the maize in there. And so we are looking at doing a partial or a full replacement dependent on the results that we are going to gather. And then the second one, sorry, Prof, that has skipped me.
I think the question was, why would you think of replacing maize with sorghum?
Okay, so on nutritional basis, yes, they are comparable. On nutritional basis, they are comparable. And I think that you asked why in Ghana. Why in Ghana? Because it's not fully utilized or explored, especially when it comes to poultry feed. And a lot of it is mainly used up north rather than the middle belt and then down south. So I think we going that way is a bold move to look at, I mean, swaying the pressure that is on maize so that we could get an alternative, sustainable energy source.
Let me rephrase it. What advantage are we going to get if we replace maize with sorghum? What advantage?
Okay, so economically, we have been looking at total cost of production over and over again. And the issue about maize being expensive and what have you has mainly got to do with other price elements, such as shortages. So if we have sorghum coming in now, it comes to stabilize a lot of our total production costs and as well as give us economic benefits.
What's the comparative price between sorghum and maize in Ghana now?
Okay, so the last time on the market I checked, maize was going at 7 cedis, but since that time per kilo. Since that time, it has dropped again. That is why I mentioned that there are quite a number of price windows, and all of these affect the total cost of production. And then that of sorghum is about 8 cedis per kilo price.
So even now, sorghum is more expensive?
Slightly.
Even now, sorghum is more expensive?
Yes, please.
Is sorghum the grain they use for making...
yes, but there are different varieties.
Okay. I mean, I don't have a problem with your work if it's for academic reasons, but just the fact that it's not being utilized, it's not a justification for utilizing it. No farmer here will buy sorghum at 8 cedis and replace meat at 7 cedis. I'm sure they are not that stupid. See, they want money. I'm not condemning your work, but I'm saying that we need to be a little more practical in some of these issues. I mean, chicken feathers, the example that I usually give is chicken feathers. They contain 85% crude protein, but nobody asks it to feed. Surely chicken feathers will be very abundant in this country. But nobody uses that because we know that it doesn't improve. In fact, it has an adverse advantage on performance. So the fact that it's not being used is not really a justification for trying to use it. Unless you are going to reduce the price and you are going to assure us that the people in the north are now going to start producing more sorghum so that when you use sorghum from January to February, you don't have to run around looking for sorghum in June or July. Do we have any guarantee that if all the farmers decided, oh, we are going to sorghum, they are not running out of sorghum after 1 month?
Well, farmers, yes. I mean, obviously, if they know there is good value for sorghum economically, they would want to go into it because it's drought tolerant. And it also would have a policy direction. So,
yeah, thank you very much. I think I agree with Prof. Osei. But as scientists, not all the work we do have economic sense. We are only interested in the science. We have done a similar work where we used the sorghum, soaked it for 72 hours, then used the unsoaked, and then against maize. And we realized that feeding the soaked sorghum depressed growth performance. Maybe it's because of the leaching of nutrients. So a similar work has been done. I just want to inform you. But as far as the economics is concerned, I don't think we want to replace maize with sorghum in Ghana. Elsewhere in other countries, they use sorghum in feeding chickens. But here in Ghana, we use sorghum for a lot of things, Hausa cocoa, kose, and the rest. So you can't go and tell any poultry farmer to use sorghum. But I think you are in for the science, the academic purposes. Yeah. Thank you.
all right, so I'll contact you, please, for the work that has been done.
Musa. Okay. Do we have wampons? Factors influencing antimicrobial use and resistance among local chicken owners within the Cape Coast municipality. Good. Adedoyi. Okay. So we'll have a presentation from Dr. Adedoyi, growth response, hematology, and intestinal health in broilers fed Saint leaf meal.
Good afternoon, Mr. Chairman, professors in our midst, and distinguished colleagues. The title of my project is Growth Response, Intestinal Health, growth response, hematology, and intestinal health in broilers, pheasant leaf meal, and synthetic antibiotics. Introduction. Broilers are one of the domesticated birds kept either for meat, eggs, or feeders. And from the research of Array et al. 2010 and FAO 2023, they are good to be integrated into many farming systems. And from the use of synthetic antibiotics, it has been noted that the mainstay of industry it has been noted that synthetic antibiotics have been the mainstay of the industry in controlling infections and promoting growth of the birds. They are equally useful for the food security globally. Looking at the work of Fast et al. 2015 and Thompson 2017, these domesticated birds are also fit into urban and peri-urban production, because when you look around, you will discover that an average family has rearing of broilers in either urban or peri-urban. Then worldwide poultry meat consumption is about 13.6 per head, varying from 1.77 in India to 58.81 in US. But it has been noted that the consumption of this poultry meat is drastically low in the developing countries like Nigeria. The development in the sector is, however, constrained by many factors, including diseases, an outbreak of which sometimes causes serious setback in the enterprise. Meanwhile, the continual usage of synthetic antibiotics in livestock production leads to the resistance of the microbial pathogen. And this has prompted research to find alternative sources, such as scent leaf, which is widely grown as a perennial herb in tropical Africa. And this is rich in phytochemicals such as alkaloids, flavonoids, venols, and terpenes, as reported by Weze 2020 and Adidoye 2023, which has been studied for its microbial and antioxidant properties. The objective of this study is to compare the growth response, hematological and intestinal health indices in broilers, fresh scent leaf means, and synthetic antibiotics. Materials and methods. The research was conducted in the poultry farm, Jamari Farm in Nigeria. A total of 300-day-old harbor hectare broilers. Chicks were used for the study. Broilers were randomly allocated to 6 experimental treatments and were brewed for 1 week. Each group was assigned 50 balls per treatment after brooding. Then the study lasted for 7 weeks. Data collected were on feed intake, weight gain, feed conversion ratio, mortality ratio were also assessed. Then weekly weight was determined by difference in the weight at the beginning of the week and the weight at the end of the week. Feed to gain ratio was estimated as the ratio of feed intake divided by body weight gain, while the number of dead birds were divided by total number in the treatment as multiplied by 100, used to calculate mortality ratio. Then organs weights were taken in an electronic weighing scale. Relative organs weight of gizzard, kidney, liver, and heart were also measured. Then weight of organs, kidney, liver, and breast weights were taken. It was calculated by taking the weight of respective organ by divide it by the body weight of individual birds, then multiply by 100. Blood samples were taken at the end of feeding trial. Birds were starved or feed overnight before taking this blood sample. Then 5 mils was used and stored in a bottle containing measure of quantities of EDTA. Then we measured PCF, Hg, then red blood cell, white blood cell. Then data obtained was subject to analysis of variance with software SAS 2012, the Duncan multiple range test was also carried out to separate subclass means. Then results. This is table 1. Table 1 tells us about the nutrient composition of the commercial broiler hybrid diet. Starter feed, then finisher feed. Then table 2 also tells us about the effect of scent leaf meal. They supplemented diet on performance of broiler starter. When you look at the average feed intake, then average body weight gain, the average feed intake was similar across the dietary treatment. Then the average body weight were not significant, while feed to gain ratio were also not significant. This might be due to the age-related effect, and that, okay, this might be due to age-related effects. Then when you look at table 3, table 3 talks about the effect of scent leaf meal, supplemented diet on performance of broiler finisher. Here, you can see that the average feed intake were significantly improved across the supplemented diet, and average body weight gain were equally improved. Whereas at 1% scent leaf meal supplemented diet, feed to gain ratio was better in treatment 4, that is 1% scent leaf meal supplemented diet compared to other diets. And this might be due to an effect of the phytochemicals in scent leaf meal that actually improve the nutrient utilization and absorption in broiler finisher. Then when we look at table 4, table 4 shows the hematological effect. Packed cell volume, red blood cell were not significant, including hemoglobin, but white blood cells were significantly improved compared to the negative control diet. And this might be due to the fact that the bioactive compound in scent leaf meal stimulates the macrophages within the microflora ecosystem, and this acted on the white blood cell, and that was why we have better white blood cell in the supplemented diet compared to negative control diet and positive control diet. Then on table 5 shows the relative weight organ of broiler diet, fed supplemented diet in relation to negative and control diet. When you look at kidney and liver, okay, kidney, there are no significant difference among the treatment, GSAP and heart. But when you look at the liver, starting from dietary treatment 3 T6, we can see that there were improvement. No, the liver weight at dietary treatment 5 and 6 were bigger compared to other dietary treatments. And this might be due to effect of the bioactive compound. And this suggests to us that more of alkaloids were consumed in dietary treatment 3 and treatment 5 and 6. And that was why the liver weight were bigger compared to other dietary treatments. And as we know that liver is the major organ that detoxify all these chemicals, while the kidney is like a filtering organ. So the more of work in liver made the size of liver to be bigger, in where we had 1.5 cent leaf meal and 2% of cent leaf meal supplemented the diet compared to other diets where we have less of cent leaf meal. In conclusion, this study revealed that supplementation of cent leaf meal at least 1% inclusion level holds high potential as a natural feed additive compared to synthetic antibiotics in broilers. Then cent leaf meal performed favorably with 0.5 gram per kg oxytetracycline on improved feed intake and feed to gain ratio. It has a remedy for reduction of abdominal fat. It also reduces cost per kg weight gain in broilers. However, the intake of high dosage of cent leaf meal is capable of enlarging liver size in broilers. Thank you.
Thank you very much. Thank you very much, Dr. Ade Doi. The floor is open. I'll take 2 questions. Yes, Dr. Zano and the gentleman over there.
Yeah, thank you for the insightful presentation. Yeah, but I want you to take note of your initial weight for the status. Okay. Is it 0.88 grams?
Yes, sir.
Or is a typo?
Yes.
So check it, okay? Yeah, thank you.
Okay, so mine too just is a comment. Your hematological characteristics, you made a general statement that they generally improve.
That's what?
I mean, hematological features.
Okay.
I heard that they generally improve as you increase
the level of cent leaf meal.
Your treatment. But when you take the white blood cells, we can't have white blood cells improve. That is not in a good sense, at least for the health of the animals. When you have the white blood cells increasing, it's a negative phenomenon for the animal. And then I saw that you have figures for the white blood cells, and then you now have the various forms of white blood cells. I don't know how you measure that. I thought that if you measure white blood cell together, then there was no need to now bring lymphocytes, monocytes, eosinocytes, and all that, because there are various forms of these white blood cells.
Okay.
Thank you.
Noted. Thank you. Okay. Thank you.
Our next presentation is Gaffeto, hematological and blood biochemistry profile, biochemical profile in broiler chicken fed diet containing varying levels of megathysus maximus, that's guinea grass, leaf meal as replacement for wheat bran. Dr. Izanga. Dr. Izanga, your student, is he around? Is your student around? Like, this is coming from your end, your lab. Okay. So the next one, if the present, or the student is around. Okay, as we wait for him, we may take the next presenter. Performance indices and sensory evaluation of broiler chicken meat fed black soldier fly larvae.
Good afternoon, everyone. I want to thank the chairman, and I also want to greet all the professors and the researchers present. My name is Uwa Eziozi Uche Carols, and from the University of Agriculture and Environmental Sciences, Umuago, Imo State, Nigeria. I'm here to present the work titled Performance Indices and Sensory Evaluation of Broiler Chicken Meat, Fed Black Soldier Fly Larvae, and Black Soldier Fly plus pupa scale, and its impact on the organoleptic properties. Okay. Black soldier fly is not mostly, I don't know if much people know about black soldier fly, but it's a novel area that's coming up because of its high protein content and its ability to reduce the load on the use of soya and other plant-based protein. And analyses have been done on black soldier fly. It has been recorded that it has about 50% crude protein, and this is at par with soya. And work is being done to see how it can, if it's partially replace soya or totally replace soya. So black soldier fly, apart from using it as protein in our feed, it's also, we call it nature's cleanup crew because it turns waste. What it feeds on is waste. So it turns it into protein-rich animal feed and also fertilizer for our crops. There's another good thing about black soldier fly, which is the area that people are also looking into. It is its particular nature to suppress harmful bacteria due to the bioactive compounds that it secretes while it's degrading the waste. Problem statement. The poultry and livestock industry faces rising demand for animal proteins, which I have just said, escalating cost of conventional feed, thereby creating urgent challenges for sustainable and affordable but high-quality protein production to meet global food needs. The role of BSF, for short, we call it black soldier fly, we call it BSFL. The role of BSF as sustainable protein offers sustainable protein alternative to soya meal and fish meal, providing high crude protein and essential amino acids, beneficial fatty acids and minerals, while reducing waste, feed costs, and also greenhouse emission. This study's objective is to assess the feed efficiency of broiler chickens fed these diets. Now, I want to explain what this diet is all about. The black soldier fly larvae is in the picture above. When I started, you could see the larvae. It's just like worms, okay? So we have the dried one that was dehydrated. And the other part, which people normally throw away, is the dead flies. Because black soldier fly, after 3 days of mating and egg laying, they die off. And it's not harmful to human beings. So when it dies off, most people who practice it tend to take away or throw away these the flies and the pupa scales that they come out from, that they hatch from. But we started thinking, let us analyze these pupa scales, let us analyze these flies and see if there is any benefit at all, instead of throwing them away, because SDG goal is all about waste conversion. So we decided to use it also in feed production. So the next objective was to evaluate the impact of this diet on the weight gain of broiler chickens, and also determine the effect of black soldier fly larvae and these derivatives that I called about, that's the fly and the pupa scale diet, on meat quality of broiler chickens. To also investigate consumer acceptability of the chicken, of the meat, materials and methods. The experiment was done in the poultry and experimental farm of Agmat Insight Limited, located in Imo State. And then the experimental animals, total of 90-day-old Abo Ake broiler chicks were used in a 9-week study, reared under standard brooding conditions for the first 3 weeks. So for the first 3 weeks, they were all given the conventional feed of 23% crude protein starter diet. They were also vaccinated, and every given feed ad libitum, no restrictions in feed and water for the first 3 weeks brooding. Then after it, from the 4th week, the birds were randomly assigned to 3 dietary groups, 30 birds per group, replicated 10 birds, 10 birds per replicate. Okay, we used the completely randomized design, and the crude protein levels were slightly, there were just slight variations because of the high fiber content and lipid content of black soldier fly. So we were trying to make sure that we could balance the crude protein level to be not much differ in variations. So the diet compositions of treatment A, that's the group A, which was based on black soldier fly larvae. We used 14.5% of the, that's 14.5% of the total feed was, for group A, was black soldier fly larvae. As sole protein, so there was no soya, there was no other, there was no fish meal. It was used as sole. Then the other one, that's group B, the one that has the derivative, that is the fly and the pupa. We also use 14.5%. And then the control group was 14.5% of soya and 14.5% of groundnut cake. This was, that's about 29% crude protein. I mean, 29% of the quantity of protein that was used in the feed. And in here you can see the crude protein, 19 for group A is 19.6%, group B is 18.9%, while group C control was having 20% crude protein. The statistics, we like I said, completely randomized design, and SPSS was used to analyze using ANOVA, and then the means were compared using post hoc test. The other test was sensory evaluation of the broiler meat. We used a 5-point hedonic scale and with 50 panelists. They were not informed of what was in the box. We just, these three, the three treatments, the meat, they were oven dried, that is grilled, let me use the right word. They were grilled and then put in unlabeled boxes and were given to 50 panelists. And they were to assess the appearance, the color, the texture, the smell, and taste. And results were shown in the bar chart. This is the feed composition. You can see the treatment A, B, and C, and everything that I've explained there earlier. Parameters ascertained. One was the initial body weight, final body weight, daily weight gain, total body weight, the total feed intake, the feed intake per bird per day, and the feed conversion ratio. For the sensory evaluation, appearance, color, texture, smell, and taste. This is the result. The result on the performance indices. Here, the initial body weight, you can see that they were all the same. There was no variation in the initial body weight, which gave us a good stand for the other experiment. So the final body weight, the total body weight, the daily weight gain, the total feed, the daily weight gain. Now these three, we had in the control, they were higher, significantly higher. But treatment A competed with the control group. It was very close. Though it was statistically different, but it compared favorably with the control group. As we can see in the feed conversion ratio, the control group had 3.56 and followed by the treatment A, that is the one with the black soldier fly larvae, which had 3.93. But that of treatment B, the one with the scales and the fly, was very high. And this can be likened to the cheatings on the scale of this, the fly and the pupa scale. Cheatings, of course, can reduce bioavailability of nutrients, the protein and the bioavailability of nutrients for the absorption in the body. So the impact, it showed this had impacted digestibility and nutrient absorption. These aligns with the Borelli et al. 2017. Feed intake had no significant difference across treatments. This indicates palatability across all the treatment groups. So here we have to just focus on optimizing utilization, nutrient utilization, because all of them accepted their feed without issues. The mortality rate, there was no death across all treatments. So this suggests that the derivatives are safe. The BSF derivatives are safe for the birds. This is the sensory evaluation of the broiler. We can see here that the panelists for Group A and Group B. Group A is the larvae, while Group B is the one with the derivatives. So we can see that the larvae in appearance had about 80%. The Group B also had 70% in appearance compared to the control group. Control group is the one with the normal conventional feed, which had 40% in appearance. The same thing if we go, that's in appearance on good. The green shows good because the 5-point hedonic scale is for good, for satisfactory, for above satisfactory, and then for satisfactory, and for below satisfactory, and then for unsatisfactory. So these were used to grade the acceptability, the consumer acceptability of this meat. So as you can see, in the appearance, good had about 80% for Group A, while Group B had 70%. But in all these, we can see that for acceptability, Group C ranked lowest. Group C ranked lowest. Group C is the control. So, and they had no idea of what was in this box, like I said earlier. They were like, the Group C tasted like normal chicken, but Group A and Group B had more, the texture was perfect for them, the smell, and they ate more from the ones with BSF and BSF derivative. This study results show significant positive impact on flavor.
We have 1 more minute.
Okay, tenderness and overall acceptability. Okay. Overall, BSF larvae meal is a viable protein alternative with no major negative effect on meat quality, though group variations suggest optimal inclusion levels for consistency. I'll go to conclusion and recommendation. BSF as a safe protein source. Black soldier fly and derivative are safe for broilers. Also, the inclusion of pupa scales significantly lowers final body weight and daily weight gain due to chitin's impact on digestibility. So we have to minimize pupa scale inclusion or process it. We can process it using enzymes. We can process or reduce the quantity that is being added. Research recommendations. Further studies should explore optimal BSF processing methods like defattening, because fat can reduce also acceptability. So we can defatten and then give enzyme treatment, and also work on the inclusion rate to mitigate cheating negative effects and enhance growth performance and feed efficiency.
Thank you very
These
much,
are
Dr. Uwe Ziozi. Thank you for such a wonderful presentation. So I'll take 2 questions. We have one here. So let's start from. All right, Madam, congratulations on your presentation. I have a challenge starting with your title. It appears to me as though your presentation is the entire work, but then within your title, you suggested a particular emphasis on impacts on organoleptic properties. So maybe that has lengthened your presentation. In such a scenario, we expect that you only present on these organoleptic attributes, rather than going through the body weight and those things. Those will not be part of it. And then besides that, you see, you said that the title is Performance Indices and Sensory Evaluation of Broiler Chickens Meat Fed. So the indication is that we are feeding the items to meat and not live animals. I don't know if you are checking that. So these are things that you need to clearly look at so that you don't mislead. I hope this is just on the minor side, okay? Good.
Thank you very much, sir. I'll work on the title.
Thank you very much. Please, my has to do with the sensory evaluation. If I heard you right, you said that the panelists didn't know whatever that was in the box that you offered them. I was wondering, was it not probably good for you to let them know that at least some of these particular products contain this particular item? And if any of them is allergic to a product like that, the person will go ahead to eat. Though you only indicate that box A or box B has this or that. So if you are feeding something to another person, the person doesn't even know what it is, I don't think that is right to do. I stand to be corrected though. Thank you.
Thank you very much. Actually, what I meant by they didn't know what was inside was we did not tell them that group A is this, group B is this, but we actually told them what the experiment was all about. They were aware of the experiment, but we wanted them to make their own choices and give us the feedback of what they actually know what the experiment is. It's just that we did not tell them that this is this or this is that and that. Yeah.
My sister, thank you very much for your presentation. Please, I want to know the people who did the test, the sensory appreciation test, were they all given the packages, both all 3 different packages the same day? That's question 1. Please, I'll need an answer before I go.
Yes.
Yeah, the same day.
Yes, they were invited for it.
So, like, if I am one of the participants, I would taste pack A the same day. Then the same day, around the same time, I'll take pack C. I'll taste pack C. And then also around the same time, I will taste the other one, ABC, tasting them around the same
I can explain how it was done.
Thank you.
Thank you. Okay, the 50 panelists were actually invited, but we had some rules governing it. And the rules were, if you taste one, you go and drink water. We let them drink water. And before they come back. So they drank water because we wanted to use water to make sure that it neutralizes whatever taste they had in their mouth. So that was the rule we set that day. So you must drink water after each one you tasted before you taste another one.
We'll take another presentation. There is an undergraduate and postgraduate competition going on. So occasionally we'll bring in some of the students. So we're going to take a student presentation, an undergraduate student presentation. And that'll be just 10 minutes. So I think we'll go out and take our lunch. I felt we could just do the 10 minutes. If you agree, we'll just do the 10 minutes of the students' presentation, then we all go out and take our lunch. There's something different, a bit different from the pure science. Before we go out, there's more exercise.
Okay, good afternoon. Yesterday, when the editorial team met us, they gave us some information on the status of our journal. And we said some people have worked for us to get this far. And we have one of them in our midst, and there was a letter of appreciation, but unfortunately, he wasn't around, so we want to take the opportunity to present the letter of appreciation to Professor Armstrong Donko, who was the editor-in-chief for the Ghanaian Journal of Animal Science. So I will invite him here. We present the letter to him. So you also invite the former editor, Professor Okai, to do us the honor to present. So let me read the letter of appreciation. So I have the pleasure to write on behalf of the leadership of GSAP to officially show our appreciation to you as outgoing editor-in-chief of the Ghanaian Journal of Animal Science, the official journal of GSAP. Your appointment was renewed for 3 more years, ending 2 successive terms of 3 years each, which officially ends in 2025. During your tenure as the editor-in-chief, you led a team of competent editors and associate editors to move the journal from where it was to where it is presently. Now the journal is
counted among the world-class, highly reputable, and high-impact factored journals in the animal sciences in Ghana and beyond. As the editor-in-chief, you executed your role creditably by raising the journal's profile within the scientific community by ensuring that content published meet the editorial policies of the journal. On behalf of the leadership and entire membership of Ghana Society of Animal Production Fraternity, we are greatly indebted to you for your valuable service. As you retire from your role as the editor-in-chief, we hope that you will continue to support the journal and other technical advice where necessary. Thank you once again for your selfless service to the association. Thank you. So, yeah. You ask Prof. Okay. Yeah, so to hand over this letter. Yeah, so let's capture it. Where are the paparazzis? Okay, so most of you did not come to meet when the journal was in hard copies. Yeah, I think it used to be in green cover, and it moved to yellow. Yeah, so Prof. Okai and co did all the work. Those days, it was not easy to get your articles published in the journal. And most senior colleagues who reached the peak of the academic ladder had most of their papers published in the journal. And now, fortunately for us, we have the journal online. So I was there, Prof. Donko was asking me, is it the provost or the dean? Was asking, where are the copies? Now it's online. We can't find the copies. So I said, maybe you have to start printing few copies and distribute to the libraries and other places so that people will still see copies of journals. Some of us, we still want to fill hard copies. Yeah, so you print few copies and maybe we customize it so that we send them to the libraries as evidence. So we thank all of you, thank senior colleagues for the support so far. And we believe that the young ones should continue from where you left off. At this juncture, we now qualify for lunch. Oh, okay. Presentation before lunch.
Yeah. So 10 minutes for the students, and we will be straight with the time. So we invite Madam Henrietta Ajimai.
Okay. Good afternoon, senior staff. Good afternoon, ladies and gentlemen. I go by the name Henrietta Ajimai, and I'm in level 300 in the University of Energy and Natural Resources. I will be presenting on the factors influencing the choice of agricultural specialization options among students of the University of Energy. Okay. I will be presenting on the factors influencing the choice of agricultural specialization options among the students of University of Energy and Natural Resources. This will be my presentation outline. This is my introduction. Agricultural education equips students with a range of skills in science, management, communication, technology, and leadership. Agricultural graduates can pursue careers such as agricultural entrepreneurs, farm managers, animal and plant breeders, soil scientists, among others. Also, several factors influence the choice of agriculture options students choose. Perception of agriculture as a low-status career or income earning, socio-economic, cultural, and societal norms. Whereas few studies have provided reasons for the choice of agricultural specialization options by students in some tertiary institutions, So far, no study has been undertaken in the country. There is, however, the need to understand the reason for choice of agricultural specialization options by students in Ghanaian universities. This will be my objective, to identify and understand the various factors that influence students' decision to pursue various agricultural specialization options at the University of Energy and Natural Resources. My materials and methods. The study was conducted in Doma of the University of Energy and Natural Resources. The campus admits Agriculture and Technology and Geosciences. That's the School of Agriculture and Geosciences. With my research, semi-structured questionnaires was prepared from Google Form and used to collect data from 96 students from the School of Agriculture and Technology. Students respondents were randomly selected from level 100 to 400. Data collected were analyzed using descriptive statistics of SPSS into brackets, Statistics Packages for Social Sciences, version 22. Chi-square analysis was also done to determine if some demographic factors had significant effect on categorical variables. These are my results. From the figure 1, age distribution of students respondents. Looking at it, age that ranges from 20 to 25 happens to be the highest in my respondents. And this is because most of our graduates from SS mostly goes into the university right after completing SHS. And even those who stay at home within even the year, like year 1 or 2, still range like 19 to 20. So we only have 20 to 25, and the list was the 30. That will be the working individuals who tend to want to further their education for promotional purposes. Now we move to my figure 2, distribution of respondents based on program of specialization. We saw that crop science had the highest response. This is because in my school, once you are being admitted into the school as an agri student, you have the option to choose whichever specialization when you get to level 300. But when it comes to agribusiness, which was the least, once you are being admitted into the university as an agribusiness student, you complete as an agribusiness student level 400. So they didn't know the reason to answer my questionnaires. That was how come they had the least. Then we move to motivation for choice of specialization options. Where career prospects had the highest, then scholarship or financial incentives. Also, this place, I will back my results with Muwao et al. 2016, who did his work in Kenya and said, family and community had a great influence on the career prospects of most individuals. Then we move to my figure 4, primary source of information regarding specialization choice of option. Okay. Okay. Some of the students had their own, they had choice, they wanted to choose different career prospects. But this is a country where parents most of the time decide what the ward should do. Because me as a parent, I'm the one paying your fees, and I think this is where you are going to get your success, get job opportunities. Since I'm the one paying, I have high upper hand in your career. Not always, but most of the time. That's what our parents do to us. Career observation after completion of program. Most agricultural students always run away from the animal science department because they have this saying that in animal science department, there are less job opportunities. So therefore, why not venture into crop extension or other specializations? I move to my figure 6, reasons for avoiding animal science as specialization. Most of them told me that lack of practical facilities are also things that were sucking them away from our department. And indeed, it's true. My school, for instance, since the research was done in the University of Energy and Natural Resources, they are, is it less? So far, Facilities for practical experiences, we do not have. And most of the time, students tend to want to have practical experiences, which aligns with Kubani and Nkuni, who did their study in Tanzania. They say agricultural theory without practical always cause unemployment among youth after completion of their program. Figure 7, suggestion to increase student numbers in animal science options. This is most of them told me that they will need practical hands-on work instead of the more theory we do. And I will back this results also with a journal paper, which was written by Kidani in 2012. He said, theory-dominated instructions are most of the time reinforce agriculture to be updated or unappealing, whereas practical hands-on career motivates and gives a clear career path. This table is a table showing the effect of sex of students on some categorical variables concerning student choice of agriculture specialization options. According to this table, sex had a significant effect on most of the response variables, except, no, for this part, it had effect on all the response variables here. And with this particular table, it had effect on all the variables, except for the effect of previous courses on specialization options. In conclusion, agriculture specialization options are influenced by career choices, family, financial and institutional support, facilities at educational institutions. Also, practical exposure remains limited in the University of Energy and Natural Resources. Thank you.
Thank you, madam. So the floor is open for just 3 questions, then we go out and have our lunch. Question or contributions?
Okay, so you are reading Agric, eh? Yeah. So what motivated you?
Actually, I'm an home economics student who didn't have any background in agric. But my uncle told me that since I think I'm that good, why don't I try agric? Because they say agric is very difficult. And when I went into it, I didn't know where to specialize in. But with the help of our noble doctor here, he taught me few courses in level 100, and I liked the courses because they were animal courses. And since then, I decided to specialize in animal science as a whole, and that was what brought me here today. Thank you.
So you were influenced by your uncle?
Yes, please. But actually, when he told me, he didn't make mention to me that there was specialization in the department. He didn't tell me that agric has various specializations. So after I was admitted into the university, that was when few courses that were taken that were animal science. I loved them, and since then I decided to be an animal science student. And right now I'm in my 3rd year of the university.
Okay, so you are specializing in animal science?
Yes, please.
Okay.
I was going to ask the same question he asked. What he said is true. If we ask all of us here, especially the grown-ups, if you are honest, a lot of you didn't allow your children to go and do agric. So, which is true. Yeah, but reduce the way you are personalizing the work. All right. Reduce it. For now, the steady. All right. Okay. But you did well.
Thanks.
Next time, calm down small.
Is it Henrietta?
Yes, please.
Henrietta, yes. Well, that's well done. You have really done well. You know, most of the time we can't really transition from other courses to agric. It's not easy, especially, you said home econ. Yes, so I'm not going to ask you questions, but I just want to give you a pat at the back. You've done well. And Dr. Egan, please, maybe at STU, we have to reciprocate this at STU. I think we might also have slightly different or probably the same thing over there. And we should see how our students are going to respond to it. Thank you very much.
Thank you, madam.
Congratulations, my sister.
Thank you, sir.
My worry is about how we title our table. Many a times, I look at the parameters being measured, but instead of putting effects, why not effects? Because we have like 1, 2, 3, 4, 5, 6, 7, 8, 9 response variables there. So instead of having the table being titled effects of sex, why not effects? Effects of sex on students on some categories of variables.
Yeah.
Okay. Okay, thank you.
In our school, we have a diploma in agriculture where students could specialize, not necessarily specialize, but they will just pick 1 or 2 courses in their area of interest. And they also do a mini project work before they graduate. So this is a level 200 work. I think we should applaud for her. Thank you very much. Thank you. So I'm told by the LOC that we can now go out and have our lunch. Thank you. Well done. We are coming back at 3 p.m. Probably I should see him first, but I wanted Dr. Zanu to chair the session. But oh, okay. I was looking for him. Okay, so I think we'll give Dr. Bonsu a clap as we invite him to chair the session.
All right, ladies and gentlemen, would want to continue with the presentations. We are very much aware of the challenges associated with eating fufu and then coming back for presentations, but I'm sure we'll try to do our possible best to go through the presentations. And so, next presentation is going to be on the effects of bovine blood and rumen digester meal on growth performance and carcass characteristics of Japanese quail. And it is to be presented by Abdul Rahman. I don't know if they are here. Okay. In the absence of that, can we have a topic on effect of different levels of dietary energy on growth, gut health, carcass and bone traits of rows 308 broiler chickens, to be delivered by Seidu. You are here, okay. All right. Let's welcome him. So we go with the same established protocols, 10 minutes, then we have some 3 minutes of questions.
Mr. Chairman, senior members present, all protocol observed. I am Seydou Bashiro, a student of Amstead, presenting on the topic effects of dietary levels of, effect of different levels of dietary energy on growth, gut pH, carcass, and bone trace of broiler, of rows 308 broiler chickens. Actually, the work is in 2 phases, and this is the phase of the work. The outline of my presentation runs from the introduction through to results and conclusion. Dietary energy and protein are dietary factors that influences growth, feed efficiency, and economy of production. Also, energy is used to carry out activities such as muscle movement, breathing, palpation, and the like. The National Research Council energy density of 3,200 and protein of 23 and 21% for starter and finisher phases have been used over the past 3 decades as a benchmark. Also, Rose nutrient specification recommended 3,000 to 3,225 energy density and protein content of 23 and 17% under controlled conditions for Rose broilers. Hypothesis. It was hypothesized that feeding high energy diet will reduce feed intake, impair growth, bone trace, while feeding a lower energy diet will improve growth in hot climate conditions. Specific objectives. Specifically, the study investigate the effect of different dietary energy levels on growth, gut pH, carcass, bone trace, and cost-benefit analysis. In terms of materials and methods, 420 one-day-old roast 308 broilers were assigned to 5 treatments with 6 replicates with 14 bears per each replicate. Experimental diets. 2 main diets, that starter diet and finisher diets were formulated. With the starter diets, it was formulated with different energy levels, and then the finisher diets also have different energy levels. In terms of data collection, data was collected on growth, bone traits, gut pH, carcass, and cost-benefit analysis. And data collected was analyzed using general linear model version of Minitab software. And differences between means were separated using Tukey's test at 5%. This is the feed composition for the starter phase. And the differences is on the energy levels, with the protein content being isonitrogenous. So we have 3,000, treatment 1, 2,825, treatment 2, 2,900, treatment 3, 2,975, treatment 4, 3,049, and treatment 5, 3,125. Then table 2 is the finisher phase. In the finisher phase, the energy level has been increased while the protein content reduced. So in the treatment 1 is 2,900, 2,975, treatment 3, 3,050, treatment 4, 3,125, and treatment 5, 3,175. So that was the finisher diet. Now, results. Table 3 indicates the effect of various levels of energy on growth performance on day 0 to 14. It was observed that there was a significant difference among treatment means in terms of body weight, gain, feed intake, and feed conversion ratio. Bears fed that is treatment 5, that's high energy levels, performed superior, while the performance of bears on treatment 1, 2, and 3 in terms of body weight were inferior or below. In terms of feed conversion efficiency, it was observed that based on that is treatment 5, that is the higher energy level, they had a better efficiency in terms of feed conversion, and then the based on treatment 1 to 5, 4 rather, please, they perform in a similar way. On day 56, on the same parameter, it was observed that, as usual, based on that treatment 5 were superior in terms of body weight, while the performance of based on T2 and T1 were similar. And then in terms of feed intake, Based on that treatment 2, that is slightly lower or moderately lower energy diet, they were inferior or they performed below the other treatments. And feed conversion ratio was similar and efficient on bears that were fed that treatment 1, 2, and 3. The differences observed could be due to the energy density of the meal, since higher energy level can influence the utilization of other ingredients. According to Dozier et al. And Mahmoud, it was observed that higher energy level influences growth performance, especially body weight gain and feed conversion ratio. Table 5 indicates the effect of varied levels of dietary energy on gut pH of broiler chickens. It was observed that there was a significant difference in terms of gut pH for gizzard, duodenum, ileum, and ceca. Bears fed dietary treatment 3 and 5 had similar values, while the performance of bears on treatment while the performance of bears on dietary treatment while those on dietary treatment were 1, 3, and then 4 were similar. In terms of duodenum, bears on fed dietary treatment 3 and 5 were similar, they were higher, while those on treatment 2, 1, and 3 and 4 were similar. In terms of ileum pH and ceca, bears fed dietary treatment 1 and 2 were similar and differs from those on dietary treatment 5 in terms of the ceca pH. It is believed that low pH in the gut reduces the activities of pathogens. Table 7 indicates the effect of varied levels of dietary treatment on bone trace. It was observed that there was a significant difference among treatment means in terms of tibial percentage weight as well as femur percentage weight on bears served dietary treatment 2, while bears on dietary treatment 3 had the lowest mean values. On ash content, femoral ash content was superior on bears fed dietary treatment 1 and 3, while the performance of those on 2 was lower. And then in terms of breaking strength, bears fed dietary treatment 2 on femoral breaking strength were inferior, but similar to those on dietary treatment 1 and then dietary treatment 3, while the performance of bears on dietary treatment was superior. Now, table 8 indicates the cost-benefit efficiency or effectiveness of broilers fed dietary treatment, the very varied levels of dietary treatments. On per kilogram basis, it was observed that there was a significant difference among treatment means. While bears on fed dietary treatment 1 was lower in terms of cost, and those fed on dietary treatment 4 were higher. And this could be due to the price difference in terms of the ingredients, as well as the individual contribution levels. In terms of cost of feed per bed, it was observed that
2 minutes.
It was observed that bears fed dietary treatment 2 was lower, while those on treatment 4 and 5 were higher in terms of feed cost, because it was based on the cost of feed and then the amount of feed consumed. So in terms of selling price of bears, it was observed that bears fed dietary treatment 5 were expensive or higher, and this was due to the weight gain, because bears were sold based on their weight basis. And in terms of profit on feed, bears on fed dietary treatment 5 were superior, while the lowest profit was observed on bears fed dietary treatment 2. In conclusion, High energy diets enhance life weight gain and feed conversion ratio, while diets fed with 2,900, 3,050, 3,125, and 3,175 improve feed intake. Gut pH of gizzard, duodenum, and ileum were significant in varied energy diets. And carcass trays were significant at the starter phase, but gizzard weight was higher on bears fed lower energy diet to moderate energy. Next, varied energy levels on tibia and femur weight, bone mass, and breaking strength were significant. Finally, it is economical to feed high energy, to feed energy levels of 3,050 to 3,175 for higher returns. Because it has been, okay. So on this note, I will acknowledge the sponsors, that is Feed to Gain, for sponsoring or funding this project. I thank you all for giving me this opportunity to learn and then to present what I have done. Thank you so
very
much.
much. Yeah. At this point, we shall invite three questions, and then we move on. 3 questions, if there are any. Okay, please.
For the tibia breaking strength, soil, that's from Israel Soil Research Institute. Soil Research, yes, it's not all that far from here. They have a machine, a testral tester. So they normally use it to guide in terms of the bone breaking. So it's a mechanism, then a computer is attached to it. Then if assuming it's a bone, it will be set, then a knob is triggered. Yes. So when you trigger, then the amount of force that is used to break it will be recorded.
All right.
There you.
Any more? Any more? Yes, sir.
Okay, thank you for your presentation.
Thank you, sir.
I'm, however, wondering if the weight gained, was it flesh or fat? Did you check?
The weight gain, that is the.
You said that those that had elevated levels of energy gained weight better than the others. We are saying the same thing.
No, why he's asking is that you said in your presentation that those that were given the higher energy diet
had higher weight.
Higher weight gain. Then he's asking the weight gain, is it fat or the
flesh?
Yes, okay.
Did you find out?
Okay, no, I did. Yeah, because I did. No, it was the total weight of the carcass. The live weight of the bed that was considered. Yes, please. Fat part content. Yeah, it wasn't significant. That is column 8. 1, 2, 3, 4, 5, 6, 7, 8. Fat part content. This is the fat part. Yes, 1.0. Sorry, 1.8. Yeah, this is the fat part. All right.
Okay, so in effect, what you are trying to say is that because there isn't significant difference within the fat part, it didn't influence it. Is that not what you're saying? Okay. Please, any more? Okay, then let's give it up. Thank you so much.
All right. Thank you so much.
All right. Earlier on, I finishing the presentation, and then the presenter was in the round, he notified me that he's around now. So please, let's allow him to do that for us. That is on the effect of bovine blood and rumen digester meal. Okay, so that is Abdul Rahman, if I get the name right. Okay, thank you. So 10 minutes. Okay. Good afternoon to senior members and colleagues and students. My name is Salifo Abdurrahman, presenting on the topic effects of bovine blood and rumen digester on growth performance and carcass characteristics on Japanese quails. And Japanese quails, they are very small birds, and they weigh 150 grams to 200 grams at maturity, and usually they are rare under intestinal system for their meats and for human consumption. And their production is characterized by fast growth, early maturity, which is about 6 weeks old, they will start to lay. They need very small space. And they are also very prolific. They require less feed compared to birds, the normal poultry. They are more resistant to poultry diseases, and they have high longevity compared to domestic fowl, about 2 to 2.5 years. And the meat of quails and eggs are renowned for their high biological value of their protein, and they have low caloric content. And the success of the production of these birds is dependent on adequate nutrition, that is for their fast growth and so on. And protein is being the critical and expensive component of poultry diet. And in Ghana and elsewhere in Africa, feed cost constitutes 70 to 80% of total production costs. And this is the major problem of farmers here. And this feed component, the protein component, fish meal, soya bean, granules cake, and so on, they are very expensive, sometimes unavailable, and sometimes poor quality, especially fish meal. And because of this challenge, there is a need, or it's reasonable, we're looking for alternative feed sources that are locally available, cost-effective, environmentally friendly, nutritionally adequate, and less in demand for human consumption. And one of such items is blood meal. And they are those we are gotten from the abattoir operations, and they have high quality protein, 80 to 90%, and with excellent amino acid profile, lysine, methionine, and so on. And the other one is rumen digester, another byproduct from rumen of ruminant animals, cattle, goat, and sheep. And they are materials that are normally partially digested,
and they are high in microbial proteins, energy source, and vitamins. And the vitamins, especially vitamin B complex. And nutritional value of blood meal increases when they are fed with other protein sources. And therefore, that was the reason we were adding ruminant digester to that of blood to see how they will perform in their work. And therefore, the objective of the study was to determine or evaluate the effect of bovine blood, rumen digester meals on growth performance and carcass characteristics of global Japanese quails. The experiment was taking place at the livestock unit, Ikuleka Agric Department, Bolgatanga Technical University. The experiment took 4 weeks to complete. And the blood, fresh blood, rumen digester, they were collected from the Bolgatanga abattoir, transported to BTU for processing. And this is how they were processed. The bovine blood, we collected it and transported to the BTU. By the time we got there, they were clotted, they were closed, and we have to mash them, boil them 100 degrees for 15 minutes. After that, excess water was drained and cooling and mashing again. And we dried it for 2 to 3 days. After that, we use hammer millers to mill it, packaging, storage, for laboratory analysis and feed formulation. And we had the ruminant digester collection. When we brought it, there was high content of water in it. So we have to put weight to squeeze the water out. Then we dry for 3 days, milling, packaging, storage, and laboratory analysis. And these are the components of feed ingredients used in the experiment and chemical composition as well. And T0, there was no inclusion of rumen digester and that of their blood meal. Treatment 1 was 50%, treatment 2, 70% replacement, and treatment 3, 100%. And into the ratio 40-60 for blood meal and that of the ruminant digester. And we use 83 weeks old and 6 quails for the experiment, 4 treatments, 4 replicates, 5 best per replicate. And we use completely randomized design, feed and water offered at libitum. And these were the parameters we took care of: total weight gained and that of feed intake. They were monitored, average daily weight gain, average daily feed intake, feed conversion were calculated, and that of feed cost. For the carcass parameters, final weight, flock weight, carcass weight, and dressing percentage, and that of the organs were taken care of. And preliminary analysis of the blood, rumen digester, experimental diet, they were done. And we used GANSTAT to analyze the data gathered, and TEK test as a post-hoc analysis tool at 5% was used to separate meals. And this is the protein composition of the blood meal and that of the rumen digester meal. And for crude protein, 84.7, which is normally the range from 80 to 95, depending the species and when it was done. And for the rumen digester, 16.56, and all these things were within the range of other authors. And we have the growth performance of the grower quails. We have our initial weight, non-significant. We have the final weight. There was increase
2
in
minutes.
weight.
2 minutes.
There was, oh, sorry. There was an increase in weight gain as we increased the level, but by treatment 3, there was a decline, and that could be attributed to anti-nutritional factors. And for feed cost, it was, there was reduction in feed cost as we increase the alternative feed in the formulation. And for flock weights and the other parameters, there was no significant differences among those considered. In conclusion, per our results, we realized that bovine blood and rumen digester meals can replace soybean meal up to 75% without harmful effects on the growth performance and carcass characteristics. And farmers using BBRMs in feeding their birds will make a cost savings between 980 Ghana cedis to 1,340 per ton, thereby reducing the cost of production by 16 to 22%. And the other fact is that the use of BBRM in poultry nutrition will reduce the environmental impact, promote sustainable economic growth, create new business opportunity, leaning towards circular economy. Thank you very much for the opportunity.
Thank you very much, Dr. Salifu, for the presentation. Yes, Dr. Zanu.
Okay. Sorry, I think I've gone far. Treatment 1, yes. No, you are suggesting, or that is what I've done? I think I use them together. Treatment 1, we have 5.3. Yes. Yes. Treatment 1 is 0 for both, and the other one, 40, about 40 to 60. Yes. 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 That is correct, but the fact is that we are looking about the cost component, and we equally know that the fish meal currently, they are very poor, and they can contain salmonella, and most people run away from it. But what you are saying, I perfectly agree with you.
Okay, thank you. We have more questions? Right, maybe I will ask one. How did you deal with the potential problems with the blood? How did you treat it?
After taking it, we just make sure that when they are slaughtering, we take it before it gets to the ground so that we avoid contamination. That is how we collected it. And when we came, we dry on the septic galvanized.
Were the animals also assessed based on whether they had disease conditions or not?
I think the veterinarians, they are at the abattoir, and we presume
Assumption.
they do. That is their work they are supposed to do. So then, if they don't do it, I don't know. But they are supposed to check those who are sick, and they get them out.
To, but you're also a scientist going to use that product. So you should have gone a step further to ensure that their work was done. Do you agree?
Yes,
you are
but
a scientist.
Yes.
And then you are now reporting to a scientific community.
Okay.
So if you say you assume, that could be a challenge there.
All right. I didn't do that. I didn't go back to whether they were having quarantine animals somewhere. Okay. But those I saw, they were healthy.
Okay.
So I presume.
So if you can say they were healthy, that is no problem.
Oh, okay.
But to say that they were supposed to do that could undermine your results.
Okay.
Okay, maybe the last one.
Yeah. Availability. Yes, yes. I think blood meal availability is even a problem. They are causing environmental pollution. When you go near the abattoir, Bulgar, you can have about 100 and sometimes hundreds of donkeys being killed. And it's a problem. So when we started this work, people were applauding us for trying to find alternative use for that blood. They throw away polluting the environment and making residents around those areas not feeling okay. So we are even doing work. We are using the donkey blood. That work is ongoing.
Okay.
Yeah.
Okay, so maybe in future you only have to justify why the quails and not the other animals. Don't worry, that's okay. Let's give it up to him.
Thank you so much.
Okay, you're welcome. We will continue with the presentations, and then next we have something on the influence of multi-enzyme on the growth, nutrient digestibility, gut pH, and bone health in broilers fed diets containing maize bran. Okay, so we have Mr. Musa to do the presentation. So still 10 minutes.
All right. Good afternoon, Mr. Chairman, senior colleagues available, fellow colleague presenters. I'm Isaac Musa, and I'm here to present a research I carried out on the influence of exogenous enzyme on the growth performance, nutrient digestibility, bone health in broilers fed diet containing maize bran. And this is the order of my presentation. Feed has been recognized as one of the most important factors when it comes to controlling profitability in the poultry production sector. It accounts for about 60 to 80% of the total production cost. Cereal grains constitute a larger proportion, over 50% of the poultry diet, and also contribute largely to carbohydrates and to some extent protein. The most common feed grain used by most poultry farmers in Ghana is maize. But in many countries in Africa, including Ghana, maize is used in preparing most of the staple foods for humans. And it also contributes greater portion of the poultry diet, thereby putting a lot of demand and pressure on maize. So this has led to the increase in price of maize. Nonetheless, many locally available agricultural and agro-industrial byproducts, such as maize bran, wheat bran, rice bran, has been identified as suitable substitute for partially replacing or reducing the quantity of maize grain used in preparing poultry diet. Maize bran as a potential ingredient is used to reduce the quantity of maize grain that is added to the Ghanaian poultry diet. However, maize bran contains anti-nutritional factors such as phytic acid and non-starch polysaccharides. And the presence of these anti-nutritional factors make important nutrients to escape digestion in the birds. The use of feed enzyme over the years to degrade and improve the digestion of nutrients that is believed to, in feedstuff that is believed to contain anti-nutritional factors. The main objective of the study was to evaluate the influence of exogenous enzyme on the growth performance, nutrient digestibility, bone health in broilers fed diet containing maize bran. Specifically, the study seeks to evaluate the influence of enzyme and maize bran on growth performance, gut pH, carcass traits, bone health, nutrient digestibility, and cost-benefit analysis. A 2x2 factorial design in completely randomized design was employed for the study. A total of 336 500-day-old chicks were used. 4 dietary treatments were formulated, and each treatment was replicated 6 times with 14 bears per pen. The factors include maize bran at 2 levels, no versus yes. The no means no enzyme was included in the diet, and the yes means enzyme was included in the diet. The same as maize bran. The enzyme used was Rovabio. It's a novel feed enzyme that is manufactured by Addicio in France, and it contains 19 different enzymes. The treatment groups include group 1, bears fed with no maize bran and no enzyme. And then group 2, bears fed diet with no maize bran plus enzyme. And then the group 3 were bears that were fed with maize bran without enzyme. And then group 4 were fed with combination of maize bran and enzyme. Data was collected on growth performance, gut pH, carcass traits, bone breaking strength, and then apparent ileal digestibility. At day 28 of the study, 3 bears were killed, and then the ileal content was pulled and then used in the determination of the digestibility, and then cost-benefit analysis. The data was subjected to analysis of variance using the Minitab version 20.1. The results were considered significant at 5% probability level, and then the key LSD means separation test was used to make comparison between the means. And this is table 1 shows the composition and calculated analysis of the experimental diet. From the table, T1 and T2, that is diet 1 and diet 2, they were having high level of maize grain, but no maize bran. And then T3 and T4, they were having low level of maize grain and then high level of maize bran. The maize was reduced because the Rovabio enzyme is believed to contain 19 different enzymes. So we did that with the mind that when we include the enzyme in the diet, it will be able to increase the energy and then protein and then fat digestibility, thereby compensating for the energy deficiency that was accounted for in the treatment 3 and the treatment 4. And then 0.03% of the enzyme was used in the study. And this in phytase unit was 1,500 FTU. On growth performance at day 14, enzyme as a main effect, there was an interaction for FCR and feed intake. And from the results, when maize bran was fed in isolation to the bears, the efficiency of the feed was very poor. But then when the enzyme was added to the maize bran and fed to the bears, we realized that the efficiency of the diet improved. Same as for the intake. When we fed maize bran in isolation to the bears, we realized that there was decrease in feed intake. But then when the enzyme was added, there was an increase in the feed intake. On day 28, enzyme as a main effect had no significant effect on all the parameters measured. But then maize bran as a main effect had significant effect on body weight, gain, and feed conversion ratio. Bears that were on the maize bran diet had a reduced body weight and gain. At the same time, poorer feed efficiency as against those that were not fed with the maize bran. This is because maize bran contains some level of non-starch polysaccharides, and the presence of this non-starch polysaccharide increases the digester viscosity, thereby limiting nutrient absorption in the gut, which might have contributed to the poor performance that was seen in the bears on the maize bran diet. On gut pH, there was an interaction for the jejunal pH. When maize bran was fed in isolation, there was an increase in the pH of the jejunum. But when the enzyme was combined with the maize bran, we realized that there was a decrease in the pH in the jejunum, which is a sign of being beneficial for the bears, because maize bran contains some level of soluble fiber, and the presence of this soluble fiber can be fermented by gut microbes. So this might have produced short-chain fatty acids like acetic acid, butyric acid, and propionic acid, which might have reduced the pH in the jejunum. On carcastrate, maize bran as a main effect had significant effect on gizzard weight and then breast weight. From the results, bears on maize bran had higher gizzard weight as against those that were not fed with the maize bran. This is because of the presence of fiber in the maize bran, which might have increased the workload on the gizzard, thereby leading to muscular hypertrophy and making the gizzard to increase in weight. And then with respect to breast weight invariably has direct correlation with body weight.
2 minutes.
Okay. With body weight. So the presence of has direct correlation with body weight. From the body weight results, we realized that based on the maize bran that had a reduced body weight, so that translated in the lower breast weight that was seen. And then enzyme had significant effects on fat part, and based on the enzyme had higher fat parts against those that were not fed with the enzyme. From the digestibility results, I will get there and explain it better. And then on breaking strength, day 28, there was no significant effect on breaking strength, but on day 56, tibial breaking strength and femur breaking strength were influenced by the presence of maize bran. And based on maize bran diet had a reduced tibial breaking strength and femur breaking strength. And this is because the diet was high in fiber. And we know calcium and phosphorus are the determinants of bone development. And the diet that was formulated with the maize bran had low level of calcium and then phosphorus. That might have contributed to the low strength detected. And then on digestibility, we realized that there was an interaction for fat digestibility. And when maize bran was fed in isolation, it decreased digestibility of fat. But when enzyme was added, there was an increase in the digestibility of fat. So you can see why in the carcass analysis, we had higher fat part in based on the enzyme diet. And then with respect to cost, there was an interaction for profit per bed and a net income. Based on maize bran had a reduced profit and then net income, as those on the no maize bran that had higher profit and net income. In conclusion, the addition of enzyme Rovabio to maize bran diet resulted in better growth performance of the bears at the early stages of the production cycle. Inclusion of enzyme maize bran diet decreased pH of the jejunum of the bears. The inclusion of maize bran and no enzyme diet increased empty gizzard weight, but percentage body weight. Feeding bears with maize bran decreased breaking strength of tibia and femur of the bears. Fat digestibility was significantly affected by both enzyme and maize bran inclusion, indicating that it was in the presence of the enzyme that maize bran was able to influence fat digestibility. Enzyme inclusion increased feed costs, but then increased revenue, hence increasing the net income. It is recommended that maize bran, as the one used in this study, is recommended for Ghanaian poultry farmers to reduce the quantity of maize grain used in feed preparation by supplementing it with exogenous enzyme. I would like to acknowledge Feed to Gain in the United States for providing the funding for this study, and also Addicio in France for supporting us with the enzyme Rovabio for the study.
Thank you.
Thank you.
Let's take let's take questions. Yes, please. The floor is open for questions. Yes, sir. Please start.
Thank you for your presentation. But you did fat part.
Yes, please.
And those on the enzyme were worse off.
Yeah, they had increased fat
and you say we should eat the fat. You are recommending that we should use it. Because if it's all fat, these days everybody is conscious about their health.
Yes.
So maybe we have to find a way of trying to contain that. We don't want too much fat in our meat.
But then the fat
Thank
recorded in this study as against the recommended fat level for consumption, it didn't exceed it.
All right, thank you. Any further? Yes, sir. Dr. Diodu.
Yes, please. Okay. We use best because of the design that I employ. I wanted, before employing completely randomized design, there are certain factors that you need to take into consideration. That is the homogeneity of the experimental units. So one, age is part. So the best has to be of the same age. That is why. The treatment. Yes, please. Okay, because we use the same breed. We use the same breed in the experiment. I didn't consider that.
My point is, how do you attribute the difference to the treatment alone? Whilst you are not sure whether the
I want to make a comment.
the same genetic makeup or not.
Okay. You are referring to the individual birth differences. Okay.
Can I make a small comment?
Please do, sir.
I thought you said the birds were from the same.
Yeah, they are of the same.
You source them from the same supplier?
Yes.
So the genetics should not arise. If they are from the same breed, same supplier, it means they are coming from the same parent stock. So
they were hatched the same
yes,
time.
so the genes will not be different.
But then, Doc.
This is a little debatable, but what we have to do now is that whatever we do,
and
even twins, as in humans, you can have some variations. And so these little variations, I think, for the meantime, would be permitted so that we can move on. Yes, I didn't even see.
Yeah, I would suggest everybody here should buy Aizanga's book on experimental design. I think it gives a very detailed information on how to design, how to take care of errors which are beyond your control. That is why you have what you call, it's a 5% margin of error. So you leave that chance that whatever will happen, you are not 5% sure. You are 95% sure. So if this work is repeated, you are 95% sure that you will get the same result. You are 5% unsure. That is why in the medical field, you leave chance to 0.0 because 1% sure. If there is death, 1 person dying is serious. But for agricultural experiment, you say 95%. So go and buy Aizanga's book. That will help you.
All right. Okay, so Prof, what you are saying in effect is that that attribution can be within the 5%. Very good. Yes.
Yes. No.
Anyway. All right. All right, thank you, so. Okay, so thank you so very much. Let's give it up to him. We'll continue with the presentations. Up next, we have something on physiological implications of. I don't know, after eating fufu, sometimes the eyes can be a little dull. What is that? Anyway, do we have Bauer? Yeah. Yeah, not. Okay. Then outside that, we have the characterizing heat tolerance in local dual purpose and exotic chickens. You are here. Okay, let's give it up. So that is Ajimandia, right? Okay, thank you.
Good afternoon. Mr. Chairman, good afternoon. I will want to stand on existing protocols and make progress. My name is Ebenezer Ajimanduya, and I'm presenting on characterizing heat tolerance in local, dual-purpose, and exotic chickens in a tropical climate. So my presentation will go through this outline. Poultry, we know, is a livelihood source. And per this particular sitting we have today, a lot has been discussed on poultry. It is projected that demand for meat will increase, based on the fact that population is going to grow and income levels are going to be enhanced. But there is a problem with climate. A lot of the earlier scientists talked about how to use feed, enhance efficiency, and then growth, and also reduce costs. But there is another cost coming from climate that we need to pay particular attention to. It has been reported that the thermoneutral zone for most poultry is between 16 and 22 degrees Celsius. And this simply means zone whereby heat production is virtually the same as heat loss in the birds. Because of this range that we have, in developed worlds, mostly there is a use of thermocontrolled housing systems so that they can maintain the optimum temperature and humidity. But in our part of the world, poultry normally is produced exposed to ambient temperature. Heat tolerance in this study is defined as the animal's ability to physiologically adjust to high temperature humidity index levels, exposure, and also sustain productivity. In some previous studies, changes in rectal temperature has been used to assess heat tolerance in humans and in cattle. So the focus of this work is to use changes in rectal temperature to characterize heat tolerance in local, dual purpose, and exotic chickens. By way of the materials, some 120 dual purpose birds were used in first experiment. And the second one, there was the use of ROS 308 and the local Ghanaian chicken. And these birds were weighed and weight tagged for easy identification. In terms of tracking the temperature and the humidity, Govi thermohygro data logger was used. And aside that, we used a digital thermometer to check the rectal temperature of the birds on a bi-hourly basis. A THI formula showed here was used in assessing the temperature humidity index levels. By way of results, as we can see per figure 1, always when the temperature is low, the humidity levels are high. And it's been reported that high humidity level affects the bird's ability to reduce heat through evaporation. Beside that, you can see that the lowest temperature in this particular, recorded in this particular experiment, were around 28 and then 29 degrees Celsius. And this is obviously outside the thermoneutral zone for chickens. We took a look at the temperature humidity index and how it is behaving. From the first and the second experiment, you could see the trend being similar, whereby the temperatures start rising, and then it plateaus somewhere in the afternoon, and then it falls gradually. By way of the rectal temperature, upon assessment, there were no significant variation between the rectal temperature, average rectal temperature recorded for the two dual purpose. Looking at the table 2, we could see a much significance in terms of the means for the average change in the rectal temperature for the rods and then the local chicken. In conclusion, the data suggests that the temperature humidity index level are at level that induce heat stress in birds raised exposed to the ambient temperature or the ambient environment. And per the results, it suggests that the local chickens demonstrate some stability under similar temperature and then humidity index. And hence, we want to state that the local bed has some potential genetic capacity causing that particular stability. I want to take this opportunity to thank Reverend Professor Osean Ponsa, my supervisor, Professor Samuel Agri, Dr. Christopher Denyo, in helping craft this work. I must say this is an ongoing research whereby we are now trying to go into the DNA of the bird and then know the things that are working in there, enhancing that stability. I also want to mention my colleague Ricky Abuajipoku and then the team from LEPRIC that helped in getting this work done. Thank you very much.
Right, thank you. Thank you. Shall we have some 3 questions? 3 questions. Yes, Prof.
Yes, Prof.
How are the Noila, how are they different from our local chicken when they put them together? Can you differentiate among them?
I think the only thing that is clear is that these guys are structurally a little bit taller. I mean, the Noil is the dual purpose.
Which ones?
The dual purpose.
Which one? You said guys, which one? Well, the local chicken are also dual purpose.
I mean, I'm referring to them as the Noila and then the Croiler, these guys. Prof, structurally, you could see that they are a little bit taller and they, even at the same age, have some weight compared to our local chicken. But we could also use their is it feathers? Yes, to determine some differences in them. They have some
You mean their feather color?
Yes, sir.
Oh, they have a special feather different from local chicken.
Normally, I wouldn't say special, but there are some distinct in the way the plumage is compared to our local chicken that we know.
Yeah, so I'm asking this because when I see Loman Brown, at least mixed with local chicken, I can easily, when I see the cockerels, I can easily identify. I've been to places they were claiming that these are Noila, Kuwela, but I didn't see any difference between them and the local chicken. Yeah, so how sure were you that what you use were Noila or Kuroila?
I must say this work is benefiting from the African chicken genetic gain, whereby I think Erie is sponsoring the introduction of these birds. So we had direct importation of their eggs from the source. I think Etio chicken or, yeah. So we could tell that these are the birds that we are talking about.
The question that was asked by Prof. Were there no identification for these birds?
Prof, can you help me with what you mean by identification?
Yes, so he asks that if you see these birds and the local ones, I mean, difficult to differentiate them. And you gave them to various farmers, isn't it?
No, this experiment was done in-house.
It's on station?
Yeah, on station.
Oh, okay. Raise these birds alone?
Yes, sir.
Okay,
where these birds were properly tagged.
Okay, so under those conditions, the identification wasn't difficult.
Yes, sir.
All right. The temperature humidity index. I came in late, forgive me if I asked you something that. I saw that you have placed them under the 2 different strains. Is that correct?
Yeah, I must say that in efforts to synchronize receiving of the day-old chicks, we failed. So we have to restrict the seemingly one experiment to 2 different experiments. We had the dual purpose together. So we raised them first before we had the local chickens and then the ross. And we measured their temperature and humidity differently and assessed them differently.
Okay, thank you.
Any further questions? All right. So how would your work relate to poultry production?
Thank you very much. I want to say that